Good night, all.
He's
Good night,
here.
sir. Good night.
Hallelujah.
Good
Good
night. Good
evening,
night.
sir.
Yeah. Good night, one.
Hello, good night.
Night, sir.
Blessings, Sir Sean.
So if you're answering, I'm not hearing you. Hold on. Hello?
Sir, we've been answering you, sir. Are you hearing us?
Everybody answering you, sir.
You can type it in the chat.
You have football in your in the back of your background.
Well, it might be that he's not hearing us. Somebody type it in the chat, please, that we're hearing him, but he's not hearing us.
Oh, Yana. All right. So I don't know. I just need for you to continue talking because I need to sort out this device. I'm not hearing at all.
1 second, ma'am. Sir, so you're not hearing us still? Hello?
All right.
Sir?
Can somebody speak again, please? Oh, my
Hello?
goodness,
Sir?
are you still hearing me?
We're hearing you loud and clear, sir. Are you hearing us?
Thumbs up, thumbs down.
All right, I'm gonna use the thumbs up, thumbs down.
So what is happening?
All right.
All right, let's just try this again. Hello, good night.
Good night, sir.
Hey, Tash, how you doing?
I'm not too bad, and you finally you're hearing us, sir. We've been saying hello.
Yeah, I'm good, thanks. Could have been worse. But I'm good, thanks. Hey guys, trust me, I have been watching the time. Last week, this time, you know what happened? I have been watching the time. I sat down. Yes, man, I sat down and I felt the sleep coming and I lied down in the chair and I was uncomfortable and I said, nope, I'm not gonna get comfortable because you know what is gonna happen.
You drop asleep and then we're not in class again.
Me fi tell you. And then no, Christopher Shackelford I go say to me, I'm gonna foo something this man. Right? Man come to class and teacher not there for class. Say no, me do. Go about go beer out the sleep out of me eye. So let's hope.
Thank you, sir. We appreciate it.
Let's hope. No, I am happy that you appreciate it, but let's hope that at some point in time in class tonight, that sleep don't come calling at my doors. Trust me, guys. I'm just giving God thanks here. I had a scare last night. I had to drive myself to the hospital last night. I smelled uh, someone used a product that I was allergic to.
Oh dear Lord.
And I'm telling you, I isolated myself into another section of the house, and I thought I was fine until I felt my chest started to tighten. I'm not asthmatic, but I just felt my chest started to tighten up, and I was actually hyperventilating.
Sir, so you don't use antihistamine, not to pry into your business, but that antihistamine would help in an allergic situation. That doesn't help? Sir? I think my internet is lagging.
I don't think it's your internet, Natasha. No, I think it's her.
Okay. One second, I open my microphone. Okay, so sir, internet went. Sir went.
You know, so we never did about feed our schools.
Yeah. And I think sir is still kicking himself over that. Oh God. I mean, we're human, right?
I talk about me missed the last class. Think sir was at the last class. I wasn't.
Oh yeah, that's true. The last class you weren't there.
Can I ask a question? Am I the only one struggling in this calculus class?
Nope.
No,
Okay. I think I'm me alone I suffer.
no, we're all feeling it, I promise you. Sir sent us something and I was looking at it and trying to work my way around it. Anybody got a chance to look at that paper though?
I did. Me blind. Me not understand it.
Oh, well, for the first section, it's not too bad because he was showing us the ropes, the approach thing, but everything else after that sketchy, sir.
I've been watching
Alright.
videos on YouTube trying to learn,
Mhm.
trying to figure it out, and may I tell you,
Yeah, it rough. Wow.
I'm want to know how this is business calculus, because which business may I go in and use this?
Good question. I don't mean to laugh. We can
I
May
think
I work?
him did explain, man. What him did say what you use it for.
Oh,
I don't think it's calculating their salary scale. I don't think I have anything to do with it.
Him did
No.
say, you know, remember the first class?
You don't remember that?
Him say a thing about sure. Too old for this. I can't remember.
Here it is.
Yeah, yes, but fans request you know me I struggle to first believe all the time.
me I struggle. I'm like, may I do some YouTube videos, may I try learn. Some things just not make sense. Sometimes I work with a figure, I can't even get that. Most say 16x minus 12x plus 2. And no matter if you work it out back way, front way, dumb bass, anything, me still can't get the answer.
I get a better one, the one with the infinity sign. Just when you think you have it locked, then you move on to another one. It's like it's a different thing I'm asking for. So it's not that me give up. May I just send me one surfer just address some of the issues I'm having. That's all me I say.
Some of them, you know what I mean? You know, me have to find answer.
YouTube.
You know how I find answer for some of them, me have to look for, instead of knowing how to do the work, me have to look for patterns, right? So like there's one particular one with the limit for the infinity, and it has a square root on it. When we realize when it have a square root is that the right number and the left number is always what we square to find the answer. When we do it that way, then we get the answer. But me not get the answer because I know it, me get the answer because I figure out that that's how it's done.
Okay.
It's those two numbers that I use. So
all right.
Every time I do it and then click solution, the answer is correct. So I say, okay, I understand it. Not understand it, but I figure out.
Tamoya with infinity, right?
Yeah,
what you focus on are the top number name are indices. Where the top number? You focus on the highest one. So focus on the highest one,
the highest degree,
and then divide it by the others. Use a divide.
All right, the paper that you sent us, I think there's an example of that on the paper too. Anybody have that paper nearby can open it on the screen since Sir is not here just yet? All right, man, go feed. See if I can find it. I said I wasn't gonna share tonight and I'm sure I'm tired. All right, give me a minute. I go find the document.
Sir, I send message to class.
Okay.
Guys, system is dramatizing. You know what dramatizing mean?
Yeah.
You see, all the one that Marie send, me not have a clue.
All right, but find it.
Sometimes I feel say I don't because all the time I try to work out it. Me think me get it, and when I try to work out it, me can't get it. Me don't know what to do. Me stuck. Me stuck.
Well, Marie, I throw it down. That one that me can't get.
All right. On the cancel screen, let me see if this is a document, right? On the cancel this is what Sir is saying, right? The one who may talk to you about. Come on. Homework it out. What Marie just saw a while ago, going down for it.
You can't send that in the group. I got in the group.
Yeah, see here, this is the one Marie talking about. Sir said, all right, when we go back to the actual equation, the first equation is at the top where you see here, the limit with infinity, you have x to the fourth power minus x to the second power plus 7 divided by 2x to the fourth power minus 6x to the third power plus 2. How I'm do it now, each of them, since we've determined that the highest power is x to the fourth power, you divide each of these by x to the fourth power, which is the second one right here below it. You see that?
Well, we just come back on my desk. Wait, that's it.
All right, so Chana, you can resend this to me, please, in other group, so I can just email it to myself.
Yeah, I'm gonna email it to myself and then send to the group. So I'm gonna stop sharing then, right?
Yeah, more try use this and because I have the quiz for do what I'm gonna do yet. And the homework me reach at 75 and can't go no further. I would really like to get 100.
Yeah, myself too.
So what you
So me not need.
unit one
want
talk tomorrow?
Yeah, how far you reach?
I'm gonna do the quiz and get 70%. One day sure can.
I want to make sure somebody can look here. Me need 100. So understand, and then the thing is that because we are go face to face.
Yep.
Me want to make sure somebody not going there with
blind.
The basics. Right, exactly. Yes, so me I beg you just put that in the group email for me, and then tonight now, more work on it.
Yeah, I email it to myself and then send it to the group.
Percentage is the final exam for this one.
TM 60.
60 so 40% for the course. Okay.
So is this exam going to be online?
Because yeah, but you might have to do it at the school. That's I think.
Exam paper, the paper itself, the final paper, you're gonna do it at school.
Well, the midterm.
Well, they're not confirm it yet. They're not confirm it yet.
There's a meeting. Sorry, guys. I don't know if you're looking at email address. A meeting is being held on Thursday, 5:30 p.m. So
yeah,
just check it out. All right.
No, when
I have class that same time. That meeting that just to sensitize on them. As I say, them make sure keep it very short and spicy.
Yeah. All right. I'm back again, guys. But all right. So if I can just jump in, I am. What do I say? I'm going to encourage. What time? What is this? I'm going to just encourage you. It has to be short and spicy, JJ, because the semester is rather short. One of the things I would say to you is that we had a meeting yesterday, and as faculty or a select group of faculty members, and I am. I won't say anything more than that. I'm going to just encourage you all to go to the meeting, and when you go to the meeting, I would want you to speak, but speak respectfully, and trust me, it would be a decision. I quite frankly believe when you open your mouths and you speak, that the institution has no other choice but to listen. So let us not waste any energies into discussing. Yes, Papa.
Next, what them say again, kickstarted September 2021, you know, them don't show it away as nice summer, yeah. You see me? That's the worst part, that they don't see them started fresh, you know.
Yeah.
And just
Guatemala, me there.
Guatemala,
Guatemala, me there.
You couldn't bust a link for me, Bridget. A long time I know you know. You could have bust a link for me, man.
But sir, your final exam is on Edicasoft, right?
No.
Just like previous.
Hopefully. Hopefully. It should be. It should be. But anyhow, as I said before, Jesus, what is it? It's Thursday. What time is the meeting?
5:30.
Sir, are your time them coming now? Yes, it's a short semester.
To cockroach, it cut out my time.
Okay.
Yeah, but no, it is important though. I mean, I'd rather say, come meet on one Saturday, or come meet on one personal Zoom something for one Sunday to make up. But this is a meeting that I quite frankly believe that all of you should be present at, and I am going to be at the meeting now, and I will.
You really not understand it, sir.
Don't worry about it. Don't worry about it. Try not to understand it. All things will work together for good to those who love the Lord and are called according to His purpose.
Sure, speak like politicians, you know.
Amen, sir.
No, I don't
speak like a politician.
No, I'm speaking like a Christian.
Thank you. It's an amen for that. Here, it's not a here. It's an amen.
I'm speaking as a Christian. Yeah. So, anyway, let's go.
Aye.
No, let's go. All right. So, today I had an opportunity to sit back and to look at look at what it is that we have to cover, And I'm not going to scare you, but I mean, I think the ones that I had. So hold on, Zoom changed them out, Lee? Or my system are active? Oh, the ones that I would have had before, from the foundation one, would know that I am an honest and a just person. Those of you who have interacted with me before, say for example, Ophelia and I are.
Sir, me know you don't.
Ophelia and I share a good relationship. But Ophelia does something that warrants me to be very stern with Ophelia. Not because Ophelia and I are friends. It means that I'm going to compromise where I stand. And if Ophelia is my friend, and Ophelia don't do no work, and Ophelia will fail, don't Ophelia can't interfere in mind say, "Chop, me and Mr. Shan are dupes." And Mr. Shan is my daughter's godfather, so him can make me pass the course. She will feel. That's the type of person Mr. Shan is, right? I'm a fair and honest person. When I go to my bed before I finish, I have to say my gentle Jesus, meek and mild. And when I wake up on morning, I have to say, Father God, thank you. I don't want Father God box me down. So I have to be fair and honest. Now, we need to put a little bit more pep in our step. I have been going through with you, gently. We need to put some pep in our step because this is week number 3. It means that we have 7 more weeks. Matter of fact, I'm going to copy something to you. And you'll hear this. This is the only thing I will tell you that will come in a meeting on Thursday. That CCCJ has extended the date for the exam in the summer here. So I may be able to sneak in an extra week with you, and I'm very thankful for that, even though it's going to push back everything into September, but I don't mind that. What I don't want to happen is me teaching a course, a heavy course, and don't get a chance to complete the syllabus, and because of that you are disadvantaged. I'm not about that. All right, that life. So I'm going to ask you before I even put stuff together. Matter of fact, I don't feel like I want to write tonight. I'm going to be projecting some stuff, and I will do it like how we did it for Foundation Concept 1. Guys, I'm going to be seeing if I can run through and finish off the limits here and move into some other areas because time is of the essence. Please, I don't want anybody to think that, Lord Jesus, Macaroni left me down. No, I'm not about that life either. But I'm just going to ask that you just sit back, relax, get into the posture for learning. All right? All right, good. Okay, so can't even remember where it is that we left off last class, but I was looking at I remember now. So I gave you a question to look at for me to tell me what the answer is. Don't remember the question. What was the answer? I noticed I'm using an operative words because you should have done it already. What's the answer?
Yes, the answer was 1, but you say almost to see how it becomes, or 1 becomes the answer.
Oh, this was a question number 7?
You should think so, sir.
All right, cool. Anybody
yes, yes, sir. That's the question.
Thank you, JD. JD, were you able to look at the question and tell me the answer from it? Or were you able to do the question to get 1 as the answer?
No, sir.
All right. Did anybody do the question to get 1 as the answer?
Sure.
Sir, I do it and stop halfway. I'll be honest.
You do it and stop halfway. Okay. Anybody else? Listen, no. You see that little pep talk I just did a while ago? This can't happen again. When I hear the word, I'm have to do it. You understand? You notice the other part of it say, can you do these by inspection? So this is where I was last class, and this is what I wanted to develop into tonight's class. So now you are retarding me in doing the development. All right. Can you look at number 8 for me, please, and tell me if you see why the answer is 2/5?
Sir,
Maybe because of the same power.
The fifth power, and 5x to the fifth power. Everything else, I think, becomes 0.
Very good. Everybody hear that? I'm showing you these shortcuts, you know. I'm showing you these shortcuts. I'm showing you these shortcuts. So if you look at the question, you would recognize that there is the highest power there is going to be of the variable is going to be x to the fifth. Agreed?
Sure.
Yes,
Good.
sir.
So when you divide through by x to the fifth, it means that the 2x to the fifth over x to the fifth is going to leave with 2, and the 5x to the fifth over x to the fifth is going to leave with 5. Everything else, as Tashana says, will go to 0, because you're going to have a constant in the numerator and a variable in the denominator. You're going to have a constant in the numerator and a variable in the denominator. Now, when you have a constant in the numerator and a variable in the denominator, it means that the numerator has nowhere to go. It remains as is. But the denominator gets larger and larger and larger and larger and larger. And as it gets larger, the denominator that is, as the denominator gets larger and larger and larger, the function tends to 0, or the fraction tends to 0. So let me say that one more time, because I said it before. This is just recap. So if you look at it, what I tried to do just now is to put the 2/5 in color, so at least you can see what it is that it looks like there. What I'm saying to you is, once it is that you get a function that says tends to infinity, either positive infinity or negative infinity, that's what we're going to be looking at. That's what we're going to be looking at. All right? And we are going to go ahead and we're going to be dividing through by the highest power of our variable found in the question. Now, when we look in the numerator, we have x to the fifth, x to the second, x to the first. In the denominator, we have x to the fifth and x to the first. So what it is that we're going to be having now is x to the fifth. So if I divide through by x to the fifth, you can do this mentally. X to the fifth over x to the fifth is 1. So it means that my numerator is just going to be left with 2. Why, sir? Because I'm going to have 9 over x squared over 9x squared over x to the fifth. Everybody following what I'm saying?
Yes, sir.
Okay.
But I am.
All right. And then now, and if you're not following, you need to let me know, please, because we have done it before. All right. Let me
follow it, sir. Sure.
All right. Very nice. Let me just go back here. The spirit is saying to me that I need to go back. So let me just go back to something here. So this is a question. Let me just highlight something right here. Oh Lord, save me from this headache. Jesus, I pray. All right. So if you look at this question, it says the limit as x tends to infinity, and the question says 1x to the fourth, but it's really x to the fourth. We don't. So 1x x to the fourth. Yeah? We are big people, so we know that it's x to the fourth. But of course, you know that there is a magical 1 in front of x. Not that x is equals to 1, but you have a magical 1 in front of x. Minus x squared plus 7 all over 2x to the fourth minus 6x cubed plus 2. So it asks me to find a limit as x tends to infinity. But if I look at it, I recognize that x to the fourth is the highest, and it's common to both. It is the highest, and it's common to both. So if I divide through by x to the fourth, I do expect to end up with a half. So what do I mean by dividing through by x to the fourth? Let us look at the second line. The second line says x to the fourth. I'm using all the terms in the numerator and dividing it by x to the fourth. Similarly, I'm using all the terms in the denominator and dividing it by x to the fourth. All right? When I do that, I'm going to end up with my third line. Those will cancel. So because I'll have a greater value in the denominator, it means that I'll always end up with a constant in the numerator. I will not end up with a variable in the numerator when I go through and do my division. The variable will only be in the denominator. So what am I saying to you? This is what I'm saying to you. So I'll always end up with with a constant in the numerator over a variable. And as x tends to infinity, all of those variables as x tends to infinity, as x tends to infinity, copy, is
and sir, as in TENDS?
TENDS. That's what I have on the screen, but it does not see the D yet.
Okay.
It's the.
That's what I have on the screen, but it does not see the D.
It does not. You're not seeing the D yet, right? Yeah, I don't know what is happening. This COVID just makes a lot of things happen here. Oops, see there? Yeah. So that's it. So as it tends to infinity.
Okay, sir.
Right. All of that will go to 0. Right? So all you notice, and the point I was making here is that I have all constants in the numerator and variables in the denominator. Now, as the variables, as the value in the denominator gets larger and larger and larger and larger and larger, what is going to happen? That fraction is going to tend to 0. Let us talk some truth. You see, some of them will get to 0 quicker than others, you know. Like the x to the 4th, the 7 over x to the 4th and the 2 over x to the 4th will go to 0 quicker than the 1 over x squared and the 6 over x. Tell me why.
So you said the larger the number, it tends to 0, right?
So
in dividing it, the number is so it's infinity. So I mean,
no, but hear me. I'm saying to you that the 7 over x to the 4th and the 2 over x to the 4th will go to 0 quicker than the 6 over x and the 1 over x squared. Tell me why. Let me see if you're thinking. Tell
because
me why.
The fourth core is bigger.
Very good.
Bigger.
Very good. Excellent. You guys are seeing. Very good. You're seeing. The question may sound kind of rhetorical, but you know these are questions that I ask just to ensure that you guys are following what is happening. All right. I don't know why students don't like business calculus. I don't know why students fail business calculus. It's really not bad. It really isn't bad. So I'm going to give you some little tips on trying to understand what is happening. So let's go. So yes, the 2 over x to the 4th and the 7 over x to the 4th will tend to 0 quicker for the mere fact that it is to the 4th power. All right? And of course, the 1 over x squared will tend to 0 quicker than the 6 over x. All right? Let's go. So, so now I'm going to make that substitution to say that, hey, you know, if all of them tend to 0, that means we have 1 minus 0 plus 0 over 2 minus 0 plus 0. And of course, that is going to equal to a half. But guess what? We did don't see the half long time. This is our trick, you know. May I show you some secrets? All right? Nobody showed me. I had to discover it for myself. But I'm showing you this is a shortened semester, and I'm showing you these tricks of the trade. Yeah. So let us keep our secrets. Our secrets. So what's the point I'm making? So when you get a question like this on a paper, and them say, I say 5 marks, don't be too cute and get the question and say, okay, answer equals a half. You will only get 1 mark out of the 5. All right. We want to see the work out. But what I'm saying to you is there are many questions that I will be able to do, but know my answer before I start the question, because you do some mental calculation quickly. And I'm going to come to that other one when I move into differentiation, right? First principles. You can actually see what your answer looks like first, and you work towards getting that answer. You see, once you work towards getting that answer, and you get the answer, you know the teacher can ramp with your full marks you must get. So if you start this question and see the half, and when you work it out, you arrive at the half, you know, so you're right. But if when you arrive, you see, like Yana was saying, sir, I tried it, but you get mixed up in the middle, you know, sir. Yana should be able to go back and see where it is that she's going wrong. Watch me. Let me show you something here. Because you know you're supposed to get a half. The half supposed to show up itself every single time. The half supposed to be showing up itself.
Oh, I have a question, sir.
Go ahead.
On the number 6 where you've highlighted, you put the 1 before the X. I mean, it is said the 1 would be before the X. If you in the exam you cross off everything else saying that those are 0, and then you write half as the answer, you still won't get the 5. What that you still won't get the full marks for that, right?
No, miss. You see, all of them steps. When I show you a while ago another question here, I see me. So why you do it? You man, you have to show the working, man. You have to show the working. Okay. I'm only showing you the shortcut because I want you guys to see what is happening. But you see that question 6 that is being projected, where you have a question up top there, and then you can have the first step here. I want to see that. So I need to see the division. So I know you know the steps. If I don't see the division, granted, mark you. So I did say to you last class that I'm going to use a weekend to mark up the business calculus. So yes, I can tell you that I finished marking the business calculus, and a question like this came on the final exam, and not all, and it was like a 4 marks, and not all students got full 4 marks for the question because some students only wrote the answer. Wow. And some students choose not to show the division. So anywhere them leave out, and they lose a mark for that. Yeah. I don't want that to happen because I mean, you know, some students got some very good grades, and it you know, we're working towards building your GPA, you know, so you don't want to not show the steps. So you see, you know, the point I'm making, hon, and I appreciate that you said that you're being honest, you know, and I appreciate also that you tried. Maybe it's only your alone try, you know, but anyhow. Every time you're doing a question, you should be able to see every step you're supposed to be working towards getting closer and closer to what your answer is supposed to be. And until you reach a final step where you're really seeing the answer coming out. All right? So just work with me. It really isn't bad. I am not going to be doing the work, you know, for this stuff. You already have this handout, as a matter of fact. For those of you who don't have the handout, I will just ask somebody nicely to recirculate it in the group so that those new addition to the group will have a copy of this handout. I sent it off.
Sir, this document this document you're referring to?
Yeah.
Right, I just sent it back to the group for those who didn't get it, sir.
Appreciate it. Appreciate it. All right. So now let's continue. So it says now, can you see these by inspection? So can you see the 2/5 right here? Anybody, somebody?
Which question, sir? Question 7 or 8?
Number 8.
Yes, sir. It's right.
Yes, so 2 over the 5, yeah.
Very
Everything
good.
else would be 0. So 2 on the 5, since you have the highest degree is to the 5th power.
To the 5th power.
When everything else is 0, the 2 and the 5 remain.
Very good. Number 9, I have -7/2 as my answer. Do you agree?
Yes, sir.
Why?
You have 5 to the 5th power, and the 7 has it and the 2 have it, that's in the denominator, but everything else, which is lower, 0.
And guess what happened now? Go ahead, let me hear. So
-7 over +2, so it would be -7 over 2.
Okay, so look at number 8, look at number 7, look at number 8, look at number 9. Tell me what lesson can be learned from just looking at those 3 questions.
Sir, I believe they utilize the number that has the greater
power.
That.
Yeah, but there's something else.
And the position of where they are placed.
Thank you very much, Shauna K. Bogle. Buy the bus already.
Tigers.
No, man, I get the bus already, man. All right, I'm going to get the tigers for you. Very good. So you see, mathematics is the studying of patterns. It's a studying of patterns, you know. I mean, could I come to class and teach you till thine kingdom come, you don't see that pattern? Cut it. So you see what Sir did a while ago? Sir conveniently gave you question number 6 and worked through it last class.
And then you gave us 7 to go, and so I couldn't make head or tails of it. And I'm being honest, I didn't understand how you get the 1. One thing Marie looked at and she was like, 1, sir, and you say how she got it. And for the life of me, sir, how I look at it, same principle where we try to say, well, the highest degree is 4. That's x to the 4th power. Canceling it out, those would be 0. You still left with sorry?
No.
Well, I can't use the word cancel out. There's 0.
No.
Once you have
Hold up.
Okay.
Shall I?
It's in -9. So how she get 1?
Don't worry about it, because you just said something that is a common mistake by everybody sometimes. All right, look at the question again in number 7. You said a while ago that when you cancel out the x to the 4th and the x to the 4th, you get 0. It are not true. Look back at it. Yeah. And let me just stop right there because that's another pattern. JD, I'm coming back to you. Not JD, sorry. Shona K. The two are sister?
No, the man and sister, sir.
Jesus.
No.
Who? Black daily.
So me gonna sound, sir. I don't know, can be the same sister and not the same man.
Who is sister, sir? I'm curious.
No, Shona K sound like JD, man. Alright.
No. When them part together long enough, them sound like each other.
True, man. Shona K, I hope you don't give as much trouble as that JD person.
No, sir. Even girl.
Oh, she don't give trouble? All right, bless the Lord. I couldn't, you know.
That is what I was missing, sir. I forgot to put the one before the X. I mean,
thank you, please. Thank you, please.
I could kick myself, really.
No, man, it's all right, man. Don't kick yourself too hard. All right. Do me a favor now. Oh, no, you won't. Do me a favor, guys. Let me just stop here because that's one of the other things before I come back to Shona K that I need to highlight. When you cancel x to the 4th and x to the 4th, you don't have 0. You're going to have 1 that is left. Which is why deliberately I'm putting those things in blue to show you exactly what is happening. So you have to be very mindful of it. All right, very mindful of it. All right. So JD started a conversation, and her twin sister for class, finished off what it is that she was supposed to be saying. Right. Now the truth of the matter is, JD said, yeah, look on something, sir. X to the 5th, 7x to the negative 7x to the 5th, and 2x to the 5th. So, the answer will be negative 7/2. So I said that, sir. Yeah, thank you, JD. But is there anything else you can see? Shauna says, yes, sir. You have to look at the position. The position don't have to be at the start of it. My words, not hers, but that's what she means. So you have to look through the question. You notice the first 3 questions, the highest power was at the start of it, like here so, x to the 5th here so, but the one here now is at the end. So you can't look at it and say, oh, sorry, the answer is 3.
Oh.
The answer is not 3. So you have to look through the question just to ensure what is really happening. What is really happening. You know me, a food, I always give food examples. Neither one know sometimes you go and say, what piece of chicken you want? The thigh or the, everybody know the leg. The thigh or the rib or that. And you say, oh, they know the different parts of the chicken. But after a while, they know the different parts of the chicken. You understand? What I want you to do is to look at the question. Don't just look at the first 2 something. And say, sir, you have 3x to the 4th and 3x to the 4th. And that x to the 4th there has a 1 in front of it, sir. So when I cancel that, the answer is going to be 3. That was specifically written as a distractor. Why am I saying all of this to you? I'm saying all of this because I can give you a question like this on the multiple choice and ask you to determine which of the following represents that. Just look at something. Teacher show you how to do the shortcut method. All right? Okay. With that said, watch this now. Sorry. Marie, you're saying something, honey?
No. Answer is, so you want the answer for that?
Yes, please.
No, sir.
The answer is 2, sir.
Everybody agrees? I disagree.
Would it be 4 over 2, sir?
And what is 4 over 2, Ricky?
A 2.
Okay.
You disagree with that?
I may disagree.
Agree, Ricky.
So, okay. All right. Anybody else? Any other answer? Tashana said 2. Ricky said 4 over 2.
I'm sticking to my 2.
And Tashana sticking to her 2.
I'm going with 4 over 2, sir.
You're going 4 over 2.
Mm-hmm.
So Christopher, oh, you now play your number tonight.
Yeah.
Hey, Christopher, come play number man, Bridget.
You know what? I'm going to change my answer. I'm going to change my answer to 4 over 2. Yeah.
Sir, last time we play with him, me run a joke with him them way, you know, it cost me out, you know. So
no, me know that man. Me know that man.
4 divided by 2 is 2.
I was about to say that, but guess what? My answer is not 4 over 2.
Hey, and Emilio, I wouldn't get serious, you know. The voice get deeper, you know.
Yeah, like, I get deeper. I get deeper.
How can I think you can talk about my yard violate, you know? Yeah, man, trust me. Yeah, but guess what? You know, there's no way that a math class is supposed to be boring. But yeah, very good. Ricky, Chris, Tashana, Emilio, the whole of uno. Yeah, man, the answer is 2. Numero 1, 4 over 2. And you see what is happening now? This time what Sir did was not to write the answer there, because I want you to see. And what Sir did this time is put it on the inside. So just be very careful and just look at the pattern and you should be fine. As per usual.
So, sir, this one, what we would do is put everything over 4, over x over 6, right?
No.
Or,
put everything over what? Put everything. Don't help her, please. Nobody help her. Come,
Sir,
Tash.
not Google it. Not do it.
No, Tamaya, if you ever Google it to see, I take away lunch money for tomorrow. Tamaya, tell me, you can divide everything by what?
The square root? I don't know.
Jesus, Father.
Sir, I remember what you call it, sir.
No, just tell me what you dividing everything by. All right, somebody help her out. You dividing everything by what?
2x.
No, all right. Can I, sir, please?
Go ahead.
All right. So the first thing, Tom, we have to look at the degree. Where you see 6 is the highest one there, and then there's one right below it. So everything else would tend to 0. So the number in front of it is a +4 and a +2. That's what the constant. That's a constant. That's the number that you'll be left with.
Yeah. So what are you dividing everything by? So you dividing everything by what?
By the numerator, sir.
No, man.
X over 6, x to the 6th power.
Very good, Shonaki.
Right. That's what I should have said. X to the 6th power.
Right. So Tamoya, I know you said x over 6, but I know you wanted to say x to the 6, you know. And I'm only being difficult because I wanted you to recognize the error. All right.
Yes,
very
sir.
good.
No,
very
I'm glad enough, sir, because guess what happened when I did it and I was doing it on Edicosoft. I actually was doing square root and I couldn't get the answer, you know, and I tried math calculation. I actually did it to the power, and then I realized that I made a mistake. So I understand, you know, sir. And I did the wrong calculation because I kept squaring we're squaring it.
Yeah, square rooting it. All right.
Yeah.
Okay, very good. So let me just point out something again, guys. Trust me, the class started off really nice. I'm really happy that you're seeing what is really happening here. But guess what? If you notice, when I am not interested in the right answers. When Tashana said, "Sir, the answer is 2," and then people come out and say 4 over 2, and then Christopher change your answer and say 4 over 2, sir. I'm not interested.
No. Sorry, you left out something. You say your number, so I'm sorry. Even if you don't
same way, so. But you notice I said earlier that that's not the correct answer, and I'm going to tell you why I said it. So that those of you who gave me the answer quick time will be able to look at it, and those who are still working would continue working, because some people just sit down and say, okay, when I'm given the answer, me just write it down. And I don't want that to happen in my class. No, let me just stop and just say something to you guys. I want to stop and say something to you as my students, and trust me, irrespective of who you are, uptown, downtown, male or female, bright or not so bright, whatever it is that you are. I love and take care of every student in front of me, irrespective of your socioeconomic background, or what's the point I'm making? I don't teach because Yana come from the pinnacle of the hill of a Jack's Hill, and I don't teach Tashana different because she come from South. I don't do that. Never have, never will. But I want to just put in something here, and this is also deliberate. I'm taking a quick break from this so that it can percolate into our brains before I come back and hit at it again. In marking your papers, I recognize some levels of collusion with students. And like, I would have marked some papers. I know your abilities. I know your abilities. Sir, then suppose they improve. Oh yes, I can see that too. I know your abilities. But when you go and you have somebody do the stuff for you and you present it as your own, don't you have a conscience? Don't you revere God? No, come on.
No.
It's not helping you. You said no, you don't revere God. That's what you're saying. You
Him
can't.
just speak for all of us, sir. Yeah. Hallelujah. Praise the Lord.
So I'm saying to you that you cannot do that. It is dishonest. And you know what is going to happen? One person is going to get caught and is going to bear the full brunt of everybody else.
Speaking
I
of
have,
God, sir.
yeah,
I was privy to some
you're distant.
information. Sorry, you hear me now?
Yeah.
I was privy to some privileged information that is true cheating. Like they want to do this.
We
All right,
can't hear you.
I'm not hearing you. Not hearing you.
All right, now, yeah, you hear me now?
Yeah.
Yes.
I'm saying I was privy to some privileged information that is true cheating. Make them want to do face-to-face class again.
And that's one, and I can tell you straight up, that's part of the reason. It's part of the reason. And you know, we can't please, you know, can't have a cake and eat it.
Is it from the ECC?
All right. If you're speaking, I'm not hearing you.
Sorry, speak of them ago. Is it from ECC?
That I can't answer, but all I'm going to say to you that right across the colleges, we are having that level of collusion among our students. And I'm saying to you students, hear me out and hear me out well. It will not suit you. It will not benefit you. Trust me, it may look good right about now. One quick story. We offer an associate degree in math and finance at the college. And one of my students, very good student, he applied to one of these mega companies, or one of them big brand companies in Jamaica. Big brand company. When you say work with them company, then people may think say have only for money, because big brand company. And he went on the interview. And I remember supervising that student on his work experience. Got very good reviews from the whole group. And the student came back and said to me, sir, there were two of us there for the interview. I said, how it went? He said, sir, there was a graduate from the University of the West Indies in actuarial science, and me here have an associate degree in mathematics and finance. And they said to me that they were very impressed, to the point where when I was leaving, somebody met me and said to me, you did far better than the other person and you are going to be selected. To the point where by the end of the week, the student was selected. Some 5 years now, the student has been working there, would have gotten several promotions since the student would have gone there. You know, sometime later it's going to come back to haunt you. It's going to come back and catch up on you, and you're going to say to yourself, John Star, if only. You may not see it now, you know, but karma is an itch. And you know what I mean when I say itch, right?
With a B in front of it, sir.
With a B in front of it, very good, right? And when karma really comes back to haunt us, it comes back fully loaded. So I'm saying to you students, I know students and students don't work, honestly, you know.
But sir, can I say something, sir?
Go, come on, yeah.
All right, so I don't agree in cheating. I think if you do the work to the best of your ability and you go through, right? But here's something that I find interesting about, I guess, the Caribbean in a whole, or some parts of the Caribbean. It's as if when we're being taught, we're taught how to work harder and not smarter. And I say it this way because my husband just did his master's and he struggled because he was working a 12-hour shift and then going to school, and he's in the Caribbean and then going to school in England. So you must understand the time dynamics. And one of the things that he told me, that one of the reasons why he was able to pass his master's was because of what the school offered, which was an organization or a body. He said that he could write a paper and then it wouldn't say, it's not sent to plagiarism first. It's actually sent to a student body that then goes over the paper, let him know, guide him through the paper to let him know where you might have made some mistakes, where some things needed to be changed, and guided him. Because remember, you know, they can't tell you the answer. But they guide you through the paper, and then he would get the paper back within a timely manner, redo based off of the instructions, and indeed back the paper. That happened for him for calculus, for everything. There was a body for that. And I realized, even going to EXED, my first experience with college, is that there is nobody to help you through this.
All right, stop. It's not just college. The Jamaican system on a whole, the Caribbean system on a whole is like that. Tomorrow, one quick thing before we move back. You find what quote unquote don't somebody at school and make them migrate. The first thing them reach upon what a foreign.
Okay.
On a roll. Me not ask you. On a roll. And I'm saying to you because the systems are different. The systems are different. No.
And sir,
And I'm
sir,
just
this
saying,
is what I'm saying, that it's so that they're so focused on our students cheating or this and that they're not looking at what they're doing and how they're holding back the students.
And I'm saying to you, it's not them, you know. It is a system. It's a systemic issue. In Jamaica, I'm telling you, tomorrow I would have had I was one of those privileged ones, like many of you in the class. That at school, if school closed today and class parties tomorrow, them not send me a class party. Come tomorrow, I am on a plane going a foreign. You understand? And when I'm going there, I have to pack my school bag as if I'm going to school because guess what? It's not all fun and play. Them people they don't play. So I have to carry books. And I remember when I was in third form, and I had to carry my segundo libro, one big old unfortunate book that I had to be carrying up to foreign and back down to Jamaica. And I had to be going through and sitting down and studying my verbs and everything and so forth and so on. And one of my family members, who I didn't even know that she was a teacher here in Jamaica, taught in Jamaica and is teaching in the States now, came and looked into my book and said, "Hey, what grade are you in?" I said, "Oh, I'm in the 9th grade." She said, "9th grade?" I said, "What happened?" She said, "This is what first year college students are doing." I was like, "What?" And fast forward a couple years later, when I was in lower six and doing chemistry, and I took my A-level chemistry book, my cousin who was doing had completed her doctoral studies in pharmacy, one day passed the table and looked at the book and said, "What it is that you're doing?" And I told her, you know, the level calculation I was doing. And she looked at me and she said, she said, "You know that this is like about third year of college work you're doing." What's the point I'm making? It is very different. The systems are very different. In Jamaica, where we have to sit down and study and memorize formulas for going on exam to go right. Hello, the man then give the formula upon something, right? It's two different systems. It's two different systems. So it's not an Excelsior system. It's not even a Jamaica system. It's a Caribbean system.
And that's the point. And the point I get into, sir, with all of this is that whether it's not an Excel, but the Jamaican system is that they are setting up students to fail. And I don't know if it's because of economic reasons, and it has been shown. And that's why I can't wait for Thursday, sir.
No, but guess what? Tomorrow, I'm going to tell you, this is the final thing before I move on. And I want the rest of you to listen to this because this is very important. And I love when students speak out, because I don't like when people muzzle anybody. And I love when students speak because it gives me an opportunity to correct some misconceptions. So I have been teaching for quite a while. And I remember years ago, I met a student, taught the student CXC math at Excel. Student moved on and moved on to tourism, did an associate degree, taught the student in the associate degree program. The student finished, moved on to the bachelor's degree, taught the student in the bachelor's program. And I know the struggles the student went through. The student will come to school and don't have it. Literally don't have it. Literally don't have it. How you get married, sir? All me wanted us most grateful to go back home, sir, because guess what? Me are the first one in my family ever go to college. I mean, nah, fail. Me pass it. And I remember the student one day said something to me, can't tell you what it is, said something to me and asked me for a letter of recommendation. And I said to the student, I don't think so. And the student and I had a one-on-one good reasoning. Fast forward until a couple of years later, one summer like now, the student came to Jamaica and came to the college and was asking for my information. And they said to me, no, we don't give our teachers information like that. And they said, okay, I'm leaving my information. Please get in touch with him and ask him to touch base with me. And the colleague called and said, you know, such and such looking for you. And I said, blow, whoa, yeah, man. And he said, oh, because him say, yeah, him a good. I said, yeah, man, I'm a parry that man. And I called the student, and the student said, sir, I really want me if you just hang out, you know, sir. But guess what? I said, here's the plan. It was a Friday evening. I said, here's the plan. Me can meet you right about me. I said, sir, I'm going to hang out now with my high school friends then. I said, what about tomorrow? I said, sir, I left tomorrow morning on the first flight.
Mm-hmm.
He said, sir, are you coming to Florida for summer? I said, funny you ask, because I'll be there next week. He said, all right, write down the number here. Call me when you get there. My wife and I went to Florida, and I had a student number, but I just never remember who called the student. And my
remember the story.
You remember the story, right? Very good, JJ. And the last couple of days of our vacation, we went to the student's place. Assistant operations manager. Assistant operations manager.
Mm-hmm.
And I'm going to tell you tomorrow, the student wasn't a maths brain, you know. Wasn't a maths brain, but the student was very determined to learn. And I remember one day when we went and visited with him, he says to us that, boy, sir, I call him in every single day. I said, why? He said, sir, you're a black man, you know. And then give me a fight in the system because I'm not supposed to be here. They fight me out. Him said one day the system crashed, went down, no electricity, no nothing to do the system, and the computers them gone. But the weekly paid people them supposed to get them something. Him said, send piece of paper come here. Him said, and Mr. Shandy teach me maths at college. Pass piece of paper. And the boy sat down and worked out the salaries by hand for all the housekeeping staff. The manager, operations manager, did not like him and wanted something to go and hold him so you can lose him work. So when the system was restored and she put in the information, everything that the young man would have paid, would have written up for them to go down to accounts to pay, came right back to the T. Never made one mistake. And she came to him and said, how do you know to do all of this? And him turned around and said, Jamaica, I come from here. And when we go to school, we have to learn. Jamaica will come from. It reached the CEO's ears. And that boy street smart. And tell the CEO, say, here's the plan. They might big him up in a meeting and supporting him. Say, guess what? Thank you. But I am leaving. And the CEO was upset and said, leave and go where? He said, I'm leaving. Another hotel down the road is offering me X amount of money. And I've given him, said, no, come, we can match it. Nobody not offer him no money, you know. I use him hit upon the people then. And because he was such a valued worker, they ended up paying him more until he was promoted manager. What's the point I'm making tomorrow?
And this will have it. Okay, there's a future for this. If you know the stuff, the
absolutely,
you can't go wrong.
Absolutely. You see the system. You see the other systems out there tomorrow. Then get them first class honors and then get design and support and so on. But when the system fails and for you to do it on hand, because you always depend so much on a gadget to do the stuff, you have no clue how it is done. And you are crippled.
Sir, that's not for everybody.
And I'm saying it happens most times.
Yeah, but it's not for everybody because my sister did a 2-year degree in the States in accounting and got herself on a promotion. What it would have taken her 4 years here to do.
I will understand. It's the same point we're making, you know, it's just a system. So you can do it. You can do a master's in the States for in North America for 1 year. Out in Jamaica, you have to take 18 months. And if you delay upon anything, it gone to all 3 years. But the point I'm making is, it's just a systemic problem. But I can tell you, when you finish your associate degree in Jamaica here, you can go anywhere in the world with your associate degree and outshine those persons, even the bachelor's degree. That's the point I'm making. So guess what? I am saying to you, the point is, I want to do no work here. I want to do no work and do the work honestly because karma is an itch. And when she come back to come bite you, it may prevent you even from getting a promotion because you noticed you did the stuff, but you can't reproduce the stuff. All right, let's continue. So that's it. But yes, I want you now to look at this one. No, sorry, that's the answer for that one. I want you to look at this one, number 11. Can you tell me the answer for number 11, please? You're so nice. Tell me the answer for number 11.
All right. Sir, the highest degree on this is 5, but there's no other 5 there.
So what
we divide everything by x to the 5th power.
So what will happen? Talk it through now. Talk it through. Come on. I want to hear the whole class talk. Talk it through with me. Yes, Tashana, you're on the right track. Continue.
One would be in front of the X, as far as I am remembering. Kick myself for that, I swear.
Yana, Chris, Emilia, Janelle, Marie, Ophelia, Priscilla, Ricky, Shauna, Casey, Tanya.
Miss Clara, what we do now is to put the 3x over 4 by x over 5.
I'm looking at it just like
right? And the minus 4x to the third power over x over 5, then minus 7x over x over 5, and you do the same to the denominator. I think, yeah. And
do me a favor, guys. You're on the right track, JP. And I'm going to answer it because I see that you're doing the question in your head. I don't want you to miss a step. So I'm going to ask you, JD, to put it on paper. And I'm going to ask the other students to put that on paper as well. I want you to all work that question for me. I don't want to tell you. I want you to discover it for yourself. Please, look at it for me. Every one of you. Look at it. I'm right here. Let me know the answer when you get it.
But sir, the principle of it, sir, is that when you have the highest degree, which is x to the 5th power, it means that it's 1 right there. So it would be 0 over 1 because everything else tends to 0, correct?
Okay, 0 over 1. All right, okay. Okay, and what is 0 over 1?
0.
Very good, dearest. Excellent.
Because I'm looking at it and I'm like,
excellent.
There's no other x to the 5th power anywhere else, so the only one that is valid is the one in front of the x. And if everything else, the x tends to, because infinity, it tends to 0, then it must be 1. And if it's 0 over 1, it has to be 0.
Excellent. I'm waiting for the others to see it.
Sir, I see, but can we work it out?
I want you to try it first. I can, you know. As a matter of fact, I have. You notice I put some space right there because I have worked it.
I'm looking at sir. I know I'm in a seat of that.
Yes, Christopher. You know, like you play rough in a bridge. Do the something, man, passing.
My divided still. That's all.
Yeah, try it, man. Try it, please. Tamoya, I have the answer, honey, but I want you to put pen to paper just to, yes, I am being as cruel as the systemic problem, but I want you to put pen to paper, honey. Then I'm going to project my answer. Yes,
sir,
Papa.
see it to because if x to the 5th power, there are just one right there, so anything else there's a 0, you know. So see the answer, you know, sir. See the answer, man. Because everything up there's a ton 0. Because when I have nothing for cancel, I bring back some right there. So.
All right, nice. All right, so so you see what is happening here now? X to the 5th, as you all agree, is a highest term, and what we're going to be doing is dividing everything by x to the 5th. So remember, you know, when you divide everything by x to the 5th, I get that. Now look at the second part of it. Remember when you have a constant in the numerator and the variable in the denominator, and the variable in the denominator, you remember, so that didn't go to 0. So as Ricky said a while ago, sir, me see it now. Because 3x to the 4th over x to the 5th is going to leave me with 3 over x. So everything in the numerator has a constant in the numerator and the variable in the denominator. So everything in the numerator will go to 0. The only thing that will go to 0 in the denominator is going to be the 9 over x to the 4th. So technically I'm going to have 0 over 1. So you see, as x tends to infinity, we have the 3 over x, the 4 over x squared, the 7 over x to the 4th, and the 9 over x to the 4th all go into 0. So we're going to have 0 over 1, which is equal to 0. All right? Look at it.
Sir, I finally understand. We can't wait. So we can go up Edcos off.
Yeah. No, but is it that's let me just reduce it so that you can all see everything at the same time. And that's the aim. Tomorrow, the aim is to have you go on, do some reading, try some stuff, and then when I come to class, when I do the explanation, you'll see the aha moment. So you see, if you follow the rules is once it is that you have infinity, not when you have a whole number or a negative number or a numeral, when you have infinity. So once you have infinity, you're going to divide by the highest power. That's at the ongle time you're going to divide through by the terms. Ongle when you have the infinity. Ongle. O-N-G-L-E. All
Sir,
right?
repeat that for me, please.
Your ongle divide through in the limits when it is that you are finding the limit to infinity or negative infinity, positive infinity or negative infinity. All right? That's
once the infinity sign is there, sir.
Once the infinity sign is there, that's when you get the division. If the infinity sign is not there, you know what is to do. All right? So that's all you need to do. All right, good. So I'm going to give you one more for the road and then we'll just move in. So do you agree that number 12 is going to be 0 also? Look at it and tell me. And tell me why.
Number 12, sir?
Yeah, do you agree?
Looking at it.
Working it out.
So there's a 1 in front of that X. I'm looking at the
0 over 1, it's not going to be 0.
Okay, tell me why I get 0 over 1, Emilio.
X to the 8 is the largest one, so therefore they'll cancel out everything.
In there?
Everything will go to 0, so only left the X to the 8 over 1.
Okay, very good. So everything in the numerator will go to 0 since X to the 8 is the highest, right?
That is correct, yes, sir.
Very good. Excellent. Excellent. You guys see it. Very nice.
Yes, sir. I see it. Yes, sir.
Very nice. I am moving on. All right. Oh, Lord Jesus.
Undefined.
I'm saying that this one is undefined. I don't know what undefined means.
All right. So, sir, the X to the 3rd power is the highest degree in this one, correct?
No, ma'am.
I'm looking. Oh, 4. See there?
6x to 4th power.
Right. So what happened?
X to the 4th.
So what happened to think? Talk to me. Háblame.
If sir, 6 plus 0 plus all them zeros is 6. So how you get undefined? That's a conundrum.
It's a conundrum. Okay. Aha. Look at it again.
If you do the math and it's a BAP 0, 0, and also the 1 to the denominator then.
If everything get divided by X to the 4th power. Mom, let me let them out, sorry.
Sir, what's the question?
I want you to look at number 13. I wrote undefined, but I don't know what undefined means, and I want you to help me to discover what undefined means.
Well, sorry, it means each
it has to do.
All right, go ahead, Bobo.
I think it has to do with something with the largest power being the denominator. I'm not sure.
Okay. Háblame, come. What's the signal? I need to be monitoring my register because I'm seeing. Okay. I have hold on there now. So I have some people who just kind of sneak into my class and don't even hear me up. And I have to be watching those people carefully, you know. So I'm seeing two new faces, two new names. You know, I said unto them say something to me still. But well, 2.5 because this name don't look so familiar. No, 3 names. All right. So when you come class and in the first time, when you get the opportunity to say Odie or drop it in the chat, you need to do that here. All right, let's go. Tell me now, guys. Yeah, what say you? Why is it undefined? All right, do me a favor. Do me a favor. This is learning by discovery. Go ahead.
What I think undefined means is that you can't get a definite answer to the limit.
Yeah, man. Sure.
Yeah.
But tell me, use that definition now, in context to the given question. That's what I want you to do. So follow the same rules. Follow the same rules that we have been using last week into tonight. Follow the same rules. I want you to work number 813 for me. Work it, work it, work it. Put pen to paper. You know the rules. Go ahead and start for me, please. Now.
Nope. Yeah, it'll be too nasty. It'll be too nasty.
Please leave my nephew alone or my niece. Out of order. Don't load them up like that in my class, Mr. Moyer.
I'm sorry. Oh, she will reach up fast.
Sir told me you have the denominator equals 0, and to my knowledge, undefined the denominator of the 0.
Very good to sound. Very nice. Very nice. So you would recognize that when you'd have gone through your whole division, that you will have 6 in the numerator, but you'll have a 0 in the denominator. And 6 over 0 is undefined. Cannot be solved, not at this level. All right, very good. Are there any questions regarding that one?
Yes, sir. I'm not seeing the answer at the end because I'm not sure if all my steps are correct. At this point,
no, hold on. For which one? Which one there is? Which one? Number 13 or 12?
Oh, the one with 6x to the 4th.
Okay, all right, cool. Go ahead now, hon. Following you.
Because I have at one point I have 6 plus 25 over x minus 7 over x to the 3rd. Then I have 4 over x plus 1 over x to the 2nd. Is that step correct?
All right. I say it one more time, please. So you have 6 over what?
I have 6, right?
Mm-hmm.
Then I have 25 over x minus 7 over x to the third.
Oh, no. Why x? Aren't you dividing through by the highest power?
X to the fourth, no?
Right.
Right, I did that.
Oh, no. She said x a while ago, you know. Say it again now. Say it again now.
No,
Because
sir, I'm not at the beginning, no. I'm at the middle of the question. At the
sure.
solution.
Sure. Hold on. Because you're way ahead of me. All right. So do you have that Shauna K? Look at
right,
that.
I have that part,
All right.
right.
Okay, great. Okay, so Rockstone. So you can have, all right, say what it is that you have now again. Now I'm following you.
6 plus 25 over x minus 7 x to the cube divide by 4 over x plus 1 over x to the
third.
2.
X to the second, yeah.
Second, yeah.
Yeah, very good. Very good.
Right. Then I'm not sure where to go because I have 25x, then 7x to the
Shauna K.
Yes,
Don't
sir.
disappoint me, man. You're right there. This is what you say you have. You're right there, honey bunches. Go. So you remember now, you know, look at what Sir get to write. As x tends to infinity, you have to make a statement, right? So you're gonna say as x tends to infinity. As x tends to infinity, you're gonna have 25 over x. Remember, you know, it has to be in the form constant over one number. I mean, the variable. So 25 over x. You can have 4 over x also. And then you can also have 1 over x squared.
Sir, are you writing something? Because I'm not seeing anything.
Come on, I'm writing. So give me half a second and you'll see. Look at that.
I have that.
Very good. So what's the point then, Pumpkin?
So what's the answer?
You tell me. Come on. Tell me, honey. You have it.
What of the 6?
Huh? What after 6?
What of the 6? What happened to the 6?
The 6 are the stay there, sir.
Oh, because it doesn't have a denominator. Is that the answer?
No, it has a denominator.
Okay.
It don't have a variable, that's all.
Yeah, so another it look like Shauna K. 6 plus 0 minus 0 over 0 plus 0, which is going to be equals to 6 over 0.
Sir,
Yes, please.
aren't we supposed to divide everything by the highest power in the denominator?
No, ma'am. Throughout the function, not in the denominator. It's throughout the function. So you can look throughout the function to see which one is the highest.
Well, the denominator, we multiply, they divide everything by a sum.
No, man. So you see what is happening here now? So I'm going to end up with 6 over 0. You're going to have 6 over 0. But 6 over 0 is undefined. You can't have a 0, as Ricky says. You can't have a 0 existing in the denominator. Can't have a 0 existing in the denominator. Can't have a 0 existing in the denominator. All right? So that's why it is undefined. Let me just take this right here.
So you're going to send that paper, right?
I'm going to copy, no, cut. Yeah, I'm updating it. So yes, I will send the updated version to it. So let me just reduce this one so you can see everything as a whole. Bogle, I want you to, that's not it. Yeah, that's it. All right, Bogle, I want you to look at it now, honey. Or Rockstone. All right, there's a piece that went on the other page, but right. So it's, do you recognize? Can you agree with me? I want you to agree with me that I'm not doing any step that you are not already familiar with. Do you agree that it's the same thing we have been doing?
Yes, sir. Because if I was following you, I
Uh-huh.
made a mistake, but I got the same. I made a mistake, but I got the same answer as you because at the end of the day, I would have put 25 over x, 7 over x to the power of 3
Mm-hmm.
over x, and then 1 over x to the power of 2. So I got what I did wrong, sir, is that I put the 6 back beside every one of them. So when I rubbed out the 6, but I realized where the 6 went.
All right, sir.
I have an error on the
When I first looked at it and you said undefined, I said, but it should be 6. That's what I was saying. Because I looked at it, if everything else, if they where you have the limit that extends to infinity, everything else would go to, 10 to 0. So the 6 that would be left right there would be the answer. For 14, sir.
It's not 14 we're doing.
13.
Oh, because
scroll up,
your friend.
sir.
Oh, your friend. No, I don't know because I thought I had something wrong on the thing. Right. So it's 13 that I'm doing. Okay. Right. Yeah. So say it again now.
So I was saying because the 6 was there, you have to the 4th power. 6 divided by 0. I mean, it's not divided by 1, we'll get back 6. So the answer would have to, oh God, see there. Sorry, Straight, scroll up, now look on the other one a while ago.
Yeah.
About 6 over 1.
But guess what? Yeah, and that's what I just look at and confuse myself. Coming to you, Matthew, if you're calling me, coming to you. Yeah. Well, I was gonna say something, Jesus. Hold on. Right. So be reminded. What is in this lesson tonight? Be reminded that 6 over 0 is not 0. 0 over 6 is 0. So the 0 can exist in the numerator, but the 0 cannot exist in the denominator. The 0 can exist in the numerator, but the 0 cannot exist in the denominator. The 0 can exist in the numerator, but the 0 cannot exist in the denominator. All right? So 0 over 6 is equals to 0, but 6 over 0 is undefined. 6 over 0 is undefined. 6 over 0 is undefined. All right? Please just remember that. Very important. A 0 can exist in the numerator, but a 0 cannot exist in the denominator. Matthew, go ahead. All right. She don't talk to me again. Tamoya, understand? You see where we're coming from now, Tamoya?
Yes, sir, I got.
All right. Priscilla, can you unmute for me, please? Priscilla, the next one, I'm waiting room. So Tanya, unmute for me, please.
Sure, there's one little issue that's happening.
Go ahead, Papa.
Are we also doing some amount of subtraction? Like for example, in the second step, right? Where we have x to the 4th dividing x to the 3rd right there. I notice in the next line you have 25 over x. So is it that we're also doing some amount of subtraction in terms of the powers?
I know you guys never did a math course, and that question is suggesting that you forget your indices, your pre-calculus. Now remember, when we are dividing and the bases are the same, we subtract our powers. Remember that?
Yeah.
So x cubed over x to the 4th, because the bases are the same in terms of x, you're going to be subtracting the numerator power from the denominator power. So it's going to be 3 minus 4 is equals to minus 1. So your answer will be x to the negative 1, which is the same thing as 1 over x. So yes, you're subtracting your powers. So once you're dividing and the powers are the same, the bases are the same, you are going to be subtracting your powers. So that's what it is that we do. We subtract our powers in order to find out exactly what is left. Joan, can you unmute for me, please?
Yes, sir.
How you do?
Okay.
Are you understanding?
I'm following, sir.
Okay, so that's a difference. So you're following, but you're not fully understanding. What are you not understanding?
Where you?
Are you in another class?
Sir?
You in another class?
No, sir. But I just started last week, Thursday.
No, and I'm just saying, it sounds like you're in another Zoom class now.
Oh, no, sir.
Okay. Okay, so tell me now what it is that you're not seeing, Joe.
All right. Where you have the 6 plus 25 over, I get all of that.
Is that a radio or television you can turn down? Or you can relocate, please?
Oh, I'll try and relocate. All right, sir.
You have the 6 plus 25 over what?
Yeah, where you have the 6 plus and the 25 over x minus 7x. I kind of get in that part. But down the bottom where you have the 25 over x, but what you do with the 6?
Because it's a whole number. Because it's a whole number, I'm leaving it alone.
Oh.
Right. Because it's a whole number, I'm leaving it alone. So what I'm saying to you, and I want all of you to hear me now. So Tanya, I see that you have unmuted, so come to you. I want all of you to listen to what is happening here. Story time.
All right, sir.
You all right? You sure?
Yes.
No ramp with me now?
Sir, me good.
All right, bless up, bless up.
I am following and honestly I'm eating too.
All right, then cool, easy. All right. Okay, Joan. So I want all of you to listen to what is happening here. So Joan, what I'm saying to you, hon, is whenever you have a fraction, and that fraction is of a particular format, a constant in the numerator and a variable in the denominator. What is that constant in the numerator, sir? See there? 25 over x. 25 is a constant. 7 is a constant. 4 or 1 x constant. 1 or 1 other constant. Then, sir, what is a variable? See there? X. So you have x in the first case. Then you have x cubed. Then you have x again. And then you have x squared. So the point I'm making is once you have a constant in the numerator, and a variable in the denominator, it says to you that that function, as x tends to a large number, the fraction there, so is going to approach 0. It's going to approach 0. And we can do something very quickly. So if I have 1 over 1 is 1. But if I put it over 2, it is equal to 0.5. If I put it over 3, 1 over 3, I get 0.3. If I put it over 4, I get 0.25. See what is happening? It gets smaller and smaller, talk truth. If I put it over 5, it's gone to 1.2. If I put it over 6, it's gone to something else. If I put it over 7, it's gone to something else. It's by the time I reach a 9, it reached 0.1. 1. It's when I put it over 10, it reached 0.1. Right? So what is happening? The higher I go with that number, as x becomes very large, the fraction instead goes to 0 and it disappears. It disappears. So therefore, I can say to you that the whole number, the limit of a constant, finish the statement for me. The limit of a constant is the?
The constant, sir, is the actual constant.
Right. So the limit of a constant is a constant itself. Very good. The limit of a constant, Joan, is a constant itself. The limit of a constant is a constant itself. So you may say to me, then sir, 1 to the 6. Okay. It's not just 6 we're going to have, it's 6 over 0. So the limit of a constant is a constant itself. So we're going to say, okay, so the limit 6 over 0 is going to tend to 6 over 0. That's why I have a 6 over 0 here in red, right? So I'm saying to you that the limit of a constant is a constant itself. So the limit as x tends to infinity of 6 plus 0 minus 0 over 0 plus 0 is equal to 6 over 0, because the limit of the function of the constant is going to be the constant itself. But this constant, now make no sense as it is just now, because if you give me the question and put just 6 over 0, I get full marks with, You have to go tell me, say, you know, say, the function you misbehave, bad, it can't define. So we just call it undefined. We just say that the function is undefined. We just say that the function is undefined.
Okay, sir.
All right, good job. All right, let's go. Didn't plan on spending so much time on this, but guess what? If you don't understand, then you have no problem spending the time. All right, now I want you to look carefully at this one here. After this one, see there, I gave you the limit of a constant. The limit of a constant is a constant itself here. Just remember that. I'm not going to go through that. You don't have that stuff, and I'm going to update the handout. Well, I'm updating the handout as we go along. So yes, Tamoya, I will send off this updated handout. I want you to look at this one here. This one says the indeterminate form. Oh, sorry, miss, I should have told you that, you know. I should have told you that. I should have told you that. Let me just. Oh, I should have told you something, guys. I forgot. I forgot. Forgive me. All right. Now, let us look back at number 6. Let us look back at number 6. All right, no problem, hon. Let us let us look back at number 6. Number 6 says the limit as x tends to infinity of that function. We know say x tends to infinity of the function. We can look at the function, but just to inform you that that function is a function also of an indeterminate form. This function is a function also of an indeterminate form, which is going to be gonna be. Hold on, I am actually trying to put something. One of the things you'll see of me is based on the conversations coming out into the group, you'll see me updating the document as I go along, to give further explanation. So be around with me when you see me doing a lot of these typing stuff. So this is of the form infinity over infinity. And infinity over infinity is indeterminate. Infinity over infinity is indeterminate. Infinity over infinity is indeterminate. Remember I said to you that when we're doing this other stuff, I've got 0 over 0 is indeterminate. And I think Tashana asked a question. I said, when I get to that one, I'm gonna respond to you.
Yes, I remember asking that question.
Right. So infinity over infinity is also indeterminate. So it's not just 0 over 0 that you have indeterminate. Infinity over infinity is also indeterminate. And there's one other one, but I soon get to that one. So infinity over infinity is indeterminate. Are you recognized?
Sir, I have a question.
Go ahead.
The 1 over the 2, which would be the answer for this, is infinity over infinity?
So that's where I was going a while ago, to show you that when you substitute infinity into the function, what is infinity? Infinity is just a large number. So for example, say we're going to use a million. I just going to jump to the large number. Let me not use a million. That's evil. Let me use let me use 100. Because I have x to the 4. Because a million to the 4th power enough something that.
Yeah.
So let me use 100. 100 to the 4th power is plenty enough. Minus 100 squares plus 7. So in the new, if I'm saying 100 is infinity, the value that works out in the numerator is going to be more than 100. So therefore, you're going to still consider that infinity. Talk truth.
Yes, sir.
All right. And if I'm saying to you again that 100 is the infinitely large number I'm talking about, that 100 to the 4th power minus 6 times 100 to the 3rd power plus 2 is still going to be an infinitely large number, because it's still going to be a number that is greater than 100.
Yes, sir.
So I'm going to say to you that I have infinity over infinity. Once it is that we have infinity over infinity, this is what we do. We divide through the function. In this here case again, we're going to have infinity over infinity, right? We're going to have infinity over infinity. We're going to have infinity over infinity for that other one.
That makes it indeterminate, sir.
It makes it indeterminate, and this is how now we recognize that there's something in the function that is preventing the true function from coming out. That's why they have to divide. Remember I was saying to you in the other one you had to factorize? In this case, when you have the infinity over infinity, that's why we divide. We divide because it's an indeterminate form, because we get infinity over infinity. And in order for us to get the true value of our function, we have to do a simple process. What is this simple process, sir? Dividing through by the highest power in the rational function. So the highest power there is going to be 6, we divide it through by x to the 6. All right? And that's how, because remember, once we get indeterminate, it means that there's something inside of it preventing what it is that I want to come out to truly come out. So because of that, I have to go do something else. I have to do something else. All right? So I'm saying to you, all of that is infinity over infinity, right? All of this is also infinity over infinity. Because if you look at that, it's going to be equals to infinity over infinity. All right? All of what, and I'm going to send you the document here, so you don't have to worry. So number 10 is infinity over infinity. Now we need to do something else. What do we need to do? We need to divide through so we can find out our answer. So I'm jumping now to this one, the indeterminate form, negative infinity. This one here is going to be negative infinity over negative infinity, which is also an indeterminate form. So how you get negative infinity? Rockstone, so it's going to be infinity. This one is going to be infinity.
I was looking at terminal, see nothing different.
No. What is, yeah, there's something different. In the denominator here is negative. Let me just put a space right here so you can see it. The sign is negative infinity. If you look carefully down here, extending to negative infinity. Can you see that?
Oh, yes, sir.
Yeah, it's negative infinity. But all right, so let me just explain something now. So when I have a negative infinity number, all right, it's the mere fact that the power in this function is positive. When I raise a negative number to an even power, it becomes positive. When I raise a negative number to an even power, it becomes positive. When I raise a negative number to an odd power, it is negative. All right, so let me say it one more time. Let me give you an example even. Oh my God. 2 raised to the second power is 4. Negative 2 raised to the second power is also 4. But negative 2 raised to the third power is going to be equal to negative 8. So how you know that? Because it's negative 2 times negative 2 times negative 2. This is pre-calculus. If I taught you pre-calculus, you'd have seen me use these examples. So negative 2 times negative 2 times negative 2 is negative 2 all raised to the third power. And negative 2 times negative 2 is positive 4. And positive 4 times the other negative 2 is going to be negative 8. So once you raise, and that's another pattern that you'll see. All right, remember, mathematics is a study of patterns. So once it is that you raise a negative number to an odd power, your answer is going to be negative. Now, if you go back to the question that I have projected, question number 14, you'll recognize that the highest power in the function is going to be x to the 4th, which is an even power. So that negative infinity, when I raise negative infinity to the even power, the answer is going to become positive. And because it is bigger than the 25x cubed, it means that I'm going to have positive infinity in the numerator. But when you also look at the denominator, you will see me have x to the 3rd, 4x to the 3rd. Incidentally, 4x to the 3rd is smaller than x to the 4th. Can you agree with that? X to the 4th is a bigger term than 4x to the 3rd?
Yes, sir.
Yeah, man, because it is raised to one more power, right? So the highest power in the function, in the numerator and the denominator, is raised to an even power. So, or an even number, all right? So I would say to you that when I raise my negative infinity to those numbers, it will still come out to be positive. So the function there is going to be positive. It's going to be positive infinity over positive infinity, all right? And in this particular case, of course, this one will run to 6. As you would see, it works just like in the other one. You're looking at the highest power, x to the 4th. So you're going to divide by x to the 4th, so it's going to be 6x to the 4th over 6x to the 4th, and you're going to have x to the 4th over x to the 4th. Now remember, x to the 4th over x to the 4th is not 0, it's 1. x to the fourth over x to the fourth is 1. So I'm going to have 6 over 1, which is 6. So this limit tends to 6. Even though it's going to negative infinity, it is still tending to a positive number. I just explained why. Sir, can I say it quickly again? It is tending to a positive 6 because the highest power in the numerator and the denominator is even. Right. So that's why it takes a positive number. If I give you a question and I don't know if I have it, and I don't have it. So let me go with another question. Question 14. Let me do this as nope. Let me do this piece. Let me take this out. Cut. Let me put this down here. Paste. Let me get some room space, leg space between that and that. All right. So allow me now to generate another question. All right, tell me what that works out to be, guys. Hold on, let me just copy this in the meantime. Oh Lord, copy. Let me just paste it. Do you think that this is going to be positive infinity over positive infinity? Look at it and tell me.
No, if yes, sir. Negative, sir. That's an odd number.
Very good. So this one is going to be negative infinity over negative infinity. You guys are learning. Very nice. It's going to be negative infinity over negative infinity. Sir, why again? It is going to be this one is going to be negative infinity over negative infinity because the highest power in this function here is 7. So when I raise this to the 7th power, I'm going to end up with a negative, a larger negative value, if you see what I'm saying. You know, put it this way. If you owe courts $100,000, it means there's minus 100,000 you owe courts, right? And if you pay courts $50,000, they still owe them because it's going to be minus 100,000 plus 50,000, which is equal to minus 50,000. So you're still owing courts 50,000, right? So the point I'm making is because the 6x to the 7th is the largest term in that function, when I raise that to a negative number, it means that I'm going to end up with a bigger negative value, or I should, yeah, that's a conundrum if you want to talk about it when I say bigger negative value. But I'm going to have such a large negative number that even when the positive numbers are added to it, I still end up with a negative number. And because if I start with like a negative 100, because the value overall is going to be greater than negative 100, it simply means that you can say, well, if negative 100 is my negative infinity, and I have end up with negative 101, it still means that it's infinity because it's still larger than what it is that I would have started, right? So this particular one will be negative infinity over negative infinity. But sir, does it change the question? No, it doesn't. It's just that I'm saying to you, you may have negative infinity over negative infinity, which is also indeterminate. So the point I was trying to make here, which is why I wrote this other question, is to say to you that you can have 0 over 0 as your indeterminate form. You can also have positive infinity over positive infinity as the indeterminate form. And you can also have negative infinity over negative infinity. All right? So just bear that in mind. Just bear that in mind. And with that, you should be fine. With that, you should be fine. All right? So just bear that in mind. So indeterminate could be positive infinity over positive infinity. It could be negative infinity over negative infinity. It could also be 0 over 0. In DETER. All right, so I just don't want to. I want to be able to send this off afterwards. So I just want to make sure I'm making the corrections as we go. All right, so I'll have the indeterminate form right here also. All right, Okay, so I'm not going to spend more time on this because I want to move in. Remember, guys, for those of you who are just coming, forgive me, I should have said it. For those of you who are coming, this course is a 60-hour course, and as a result of that, the very first class we had some 3 weeks ago, I would have spoken to the students, and remember tonight we're going up until 10. All right. So the class is from 7 o'clock to 9 o'clock, but because we need 2 additional hours, and we came up to a consensus that will go from 7 to 10. So class won't finish at 9 o'clock. So those of you who have plans to get the last 2 hours of the curfew, I will take up 1 hour of your fun time. And then now on Thursday, guys, I don't know. It would be nice, especially that I'm going to end up giving up the 5:30 to 6:30 hour because it don't make sense for us to come back after. It really would be nice if some of you could make an effort to join me from 4 o'clock because we did say that we'll do an unsupervised hour from 4 to 5, and then we'll meet from 5 to 7. So I'm going to see if we can go, if we could meet at 4 o'clock, and we could go 4 o'clock to 5:30, at least we catch you in an hour and a half, and then I can give you the rest of the time for the class. You think that can work, JD? You think you can get a little time off early?
Sir,
Yes,
if you're an employer, will you allow? You're nice, you're going to say yes. Never mind.
Never say yes. Never say yes.
And every employer is like you, sir.
That's true. Yeah, but you see, them really want no say, boy, you go to school and we have to.
You know what one tell me, sir? Me want me go make friend with the teacher them because me gonna miss class sometime and get the recording. So no, they're not nice.
Oh my God. That's why some of them, and some of them is a JD, they never go to school, so you're brighter than some of them, that's why. Real talk. No, I tell you real talk. Some of your supervisors at work, you may not know, but some of the supervisors at work may give you a hard time to come to school because they themselves never finish. Real talk. Real talk. I have a student who should finish her degree now, and she came to the office and introduced her supervisor to me. I said, "Hey, how are you doing? Your classmate?" And my student was standing behind her, and I met monkey face up and said, "No, no, 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 no." She said, "No, sir, I'm starting my first year." I said, "Oh, you're in your first year?" And my student was in her final year at the time. So my student is more qualified than she is, and she was a supervisor in the workplace. So I'm saying to you, sometimes you get a fight, don't worry about it here. Pull through because one day you'll finish. All right. So I'm jumping from that because this here is the same thing that we have been doing, not because it's negative infinity, sir. We're going to jump up and down and say we don't know what we're going to do. We're looking for the highest power. In this here case, is x to the fourth, and then when we get our x to the fourth, we're going to divide through by x to the fourth. See here, same thing. We'll come down, same thing. We make our statement the same way. We look at what is happening. 6/1, limit is 6. The 1 year, what is the answer for this one? Tell me the answer for that one, please, quickly. Somebody, anybody.
Sorry, which one, sir? Sorry, I didn't see which one. The same one, 15?
Number 15, yeah, what the answer?
All right.
Sir, I'm kind of cross between it because the limit is negative infinity.
Don't worry about it. At the same thing, Tashana. Come, tell me the answer. Quick time. What's the answer? The same thing, Tashana.
6, sir.
7/4.
4.
Tashana.
6/4.
Very good.
Tashana. My glasses, one glasses. May I bring up the screen to my face to see it to juice?
Sure. Yeah, man. Are the same 6/4 or the same 3 halves? Don't it?
6/4, yeah. That's the negative. That's the 7th. That's to the 7th degree. I never said the bottom one, you know, sir.
Yeah, man. So it's going to be 3 halves. Yeah, same thing, guys.
So, sir, what you're saying is even if the infinity is in the negative, you still work it out and still get the answer. And you don't change it to negative at all.
Same process. Because remember, you're not substituting the values in there, you know.
There's no substitution.
You're not substituting. No, you just recognize that it's an indeterminate form, and because it's indeterminate, you're going to divide through by the highest power, which is going to be x to the 7th in this case. So you're going to go through the whole gamut and divide through by x to the 7th, la-di-la, and you know the stuff. Show you how to do it by inspection. You're going to get 6/4, which is the same thing as 3 halves. Fair enough?
Yes, sir.
Somebody was saying, sir.
2 times 2 into 6 goes 3 times.
Yeah, no? What are you saying, sir?
Sir, yes, sir, Ayana, sir. Yes, sir. Spending more majority of the class outside of the class because of dropping out. Where would you be putting this
All right, guess what? No, stop,
recording?
stop, 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 stop.
I get it, that is.
Start again now. Yana?
You can hear me now?
Come on, that's where you're coming across as
Yes,
good.
sir.
Yeah,
You hearing me?
I'm here. Yeah, go ahead.
Yeah, I've been dropping out. I've been dropping class since I came in. So I was asking, where would you be putting the recording?
I'm gonna see if I can drop it in the group. I'm gonna drop it in the
When
group.
you get it.
Yeah, I'm gonna drop it in the group.
Because I'm missing more.
Yeah, I hear you. All right, you're coming across very delayed because your internet is unstable. So see if you can just listen to as much as you possibly can. All right, mom. All right, let's go. So this is the ouch mosquito. Go and bite your mommy and your daddy and leave you alone.
Aye. Remember you're being recorded.
I know, but I'm saying no. It's a mosquito. You're biting me, and you know how much time I think about what you business. Sure.
I know, but please mute your microphone when you're telling me.
All right. Come on, mosquito, leave me alone. All right, let's go, guys. So the limit that we have done, polynomials, we have done that. The limit of the polynomial itself is that. This is what I want to move into. I would have done the polynomials with you before to say to you that the limit of a polynomial, you just substitute the values in the polynomial, and that is the answer. All right.
sir.
Yeah, that's all. Yeah, you just substitute that. All right. So let me spend. It's now 9 o'clock. Let me see if I can start and finish piecewise for the last hour. All right. Stop, sir. Do me a favor. Your bodies are just like mine. Are built in for. We know when 9 o'clock come, our body shut down. So I'm going to ask you to do me a favor.
Get up and go find ice water.
Yeah, man. I'm going to see if I can refresh myself. I'm going to give you a 5 minutes. I'm going to give you a 7 minutes, a 8 minutes break. It's now 3 minutes to 9. At 5 minutes past 9, we're going to resume. So take an 8 minutes break. Take 10 minutes break. Right?
Sir, just not fall asleep in the 10 minutes here,
Oh,
please.
Jesus. Talk truth. All right, then, cool. 10 minutes break.
Mr. Chan, good night.
Good night, Miss Sockney. Me, I wonder when you going to tell me good night to the mom.
Mr. Chan, yes, before you did start load up the new people, then I just say good night, but I never want to disturb your class and waste the time.
Miss Marlene, I divorce you.
Sir.
What going? You good?
I am good, Mr. Shand.
And you are understanding?
Mr. Shand, I am going to have to watch some videos. I am not understanding completely, but I am getting there. It's better than when I started out.
Nice. All right, no problem.
Yes.
Take a little break and then we're going to come back and start this one afresh and then you can see because this one going to go back into some of the stuff that we did. No man, the message are going too bad. All right, we soon come.
All right,
no
sir.
Man, the message are going too bad, man. I need to All right. So are we ready to go again? Hello? Anybody? Somebody?
Asleep, sir.
Oh, all right. Then, cool. No, man, they can't sleep for the thing, man. No, can't sleep for the thing. We're soon finished. We have less than an hour. We're soon finished. All right. So I want to move into piecewise function. Uh, I want to move into some piecewise function, and and I want us to have a conversation. So this is a good time for Sockney and
More limits. I can't find event topic now.
Ophelia, leave me alone.
Limits that kill me.
Sir, with the piecewise function, it involves substitution, right?
It involves substitution, yeah.
Okay.
So it's the same limit, something that we're doing, you know. So
with rules that apply to piecewise functions.
right. And what Ophelia was just saying a while ago, more limits, yes, because piecewise function deals with limits. So I'm happy that she recognizes that it's limits that we're working with. What is good for those persons joining us for the first time today will get a glimpse of what it is that we would have discussed in our own class, in our first class, sorry, a couple weeks ago. In our first class a couple weeks ago. So, let us have that conversation now. And I'm going to have that conversation by looking at a question. And the truth of the matter is that today's class, I may only be able to just look at this this one question, because you notice when I go through the stuff I go through in depth, so it is that you get a full some understanding. So those of you who are joining for the first time, those of you who are not following what it is that I was doing for the other areas, here goes a new area that we're starting. Let us get the understanding from this point, so at least you don't have much to go through when you're going through the stuff. It says determine if f of x is continuous at x equals -2 and x equals +2. Given that f of x is defined as 2x minus 1, if x is less than -2, x plus 3, if x is greater than -2 but less than or equals to 2, and if x minus 1 where x is greater than or equals to 2. So that's my piecewise function. That's my piecewise function. That's what my function is defined as. All right? That's what my function is defined as. Now, when I speak of something that is continuous, in layman's term, if I say that something is continuous, a continuous line is a line that can be drawn using your implement without lifting. Drawing that continuous line without lifting. So you just imagine you're drawing a circle, a shape, something, without lifting, a curve, whatever it is, without lifting your implement. That is continuous. For something that is discontinuous, think of you drawing something, but at some point in time, you're lifting your implement and you're continuing with the draw. It means that it's discontinuous. And it is going to be discontinuous at the point where you have lifted your implement. It now becomes discontinuous at the point where you would have lifted your implement. So what it is that you're saying is that the function exists everywhere except one place. Now, let me give you a real life example as to what that looks like. I can tell you that I will not die, not in this lifetime, from riding a motorbicycle. I can speak definitive on that. My dog is the one that can't let me down, you know. But I will not die by riding or from riding one. I will not die by jumping from an aeroplane, parachuting, negative. I will not die by going to a zoo and an animal there is going to hold on to my foot or my finger or my hand. Because if I go there, I'm not going to push my hand in there to both me and feed him. All right? So it gives me some conditionalities to it. I will die, but not by X, like those are points of discontinuity. It will not exist there. All right? You know, say, um, all right? So when I speak of something that is discontinuous, think of you drawing that line and not and lifting at several points, even one point, it means that the function is discontinuous at that point. But if you draw that line or circle or whatever shape it is, and you don't lift at all, it means that the function is going to be continuous. It means that the function is going to be continuous. All right? Now, so let's go. There are two numbers that they gave us that they want us to test to see whether or not the function is continuous at those 2 points. There are two numbers. Two numbers. I am not even interested in talking the class this week today. That should be not this week. That should be Thursday. I will say to you, determine if f of x is continuous at x equals -2. All right, I'm going to check that one day. I'm going to check if the function is discontinuous at -2 because the function is asking me to check for continuity at x equals -2 and x equals +2. So I'm checking at -2. Look at the piecewise function and tell me which functions deal with when x is equals to -2. Which two functions up there deal with when x equals -2? Look at the piecewise and tell me.
X minus 3.
And very good, that's one. And
x greater than that -2.
No man. Tell me the function. Tell me which functions.
2x minus 1.
Very good.
And x is either
X minus 3. X minus 3. No, don't look at the thing. It says x minus 3. All right, so you gave me one, and I got the other one before. All right, very good. So at least you guys are seeing it. Very nice. Some students take a long time to see that. All right, good. Watch me. What I'm saying to you is, I am checking to see at x equals -2. I'm checking to see what happens at x equals -2. So I'm going to copy that, and I'm just going to put that in. I'm just going to put this right here. At x equals -2. I'll just put in that there so that you see exactly which of them I'm talking about. At x equals -2. Now, watch me. At x equals -2. At x equals -2. Now, when we were looking at the intuitive approach, we said when I look at x equals -2, I must look to the left and to the right of -2. Anybody remember that?
Yes, sir.
Right. So once you're looking at the calculations approach, x equals -2, I'm going to be looking at the left and the right of it. So remember, sir, that means we'll put -1.9 and then -1.99 and -1.999. No, you don't have to do that. But it's just to remind you that you have to look to the left and the right of it. All right, similar to what it is that you're doing with the calculations approach, to the left and right of it. But watch me now. We know, and this is how I'm going to teach the topic. We know from week 1 that sir says you have to look to the left and the right of the function. For the function that deals with x equals -2, which of the functions on the board deals with to the left? Which of the function deals with to the left and why? I want somebody to tell me which of the functions deal with to the left, and I also want you now to tell me why. Why it deals with to the left.
X minus 3, sir.
All right, somebody speaking, but you're very low.
Because it's negative, sir.
Oh, go ahead, Chris.
Because it's negative. What is negative, Chris?
True.
All right, so let me answer the question again. Hear my question, Chris. I'm asking you, I am investigating now. You're asking to determine if the function is continuous at x equals negative 2, and if it is also continuous at x equals 2. So it's me no need to go no and go say, boy, yeah, it's continuous at both of them, or it discontinuous at both of them, or it continuous at one and discontinuous at the other. All right? So I'm saying to you, I am going to now investigate because they gave me two conditions. Condition 1 was x equals negative 2, and condition 2 was x equals positive 2. So I now need to investigate both conditions. So the first condition I'm going to investigate is x equals negative 2. So I want to look at the functions given in the piecewise function. I want to look at f of x. F of x consists of 3 different functions. I want to look into f of x and tell me of the 3 functions in f of x, which other functions deal with to the left of negative, to the left of 2, negative 2.
Would it be the one for 2x minus 1?
Why tomorrow?
Okay, because I'm just going basic, and I was always told that the negative is on the left side. So that's where I was going with my logic.
On the
and
left
it's working
side.
its way back. Yeah.
Okay. JD, why Tomoya says, okay, so Tomoya says 2x minus 1. Others would have said 2x minus 1. I agree.
Sir, I'm sorry. Our voice is very distinctive. Is Shauna K said something?
Shauna K says so, yeah,
No,
JD.
and that's fine too, you know, Shauna K. And that's fine too, you know. So Shauna K said 2x minus 1. That's fine. That's fine. What I want to get at now, Shauna K, is the answer to the other part. Because this first part was very evident. So what I really want to get, yeah man, so I see everybody can tell me now it's 2x minus 1. And that's why I agree.
What answer? So why never go x minus 3?
I mean, I asked you the question you're asking about now. All right. I just something there, you know. So that's what I'm saying to Shauna K. Yeah, man, me know you get it. Yeah, man. But tell me now, why it is that we're using 2x minus 1 and here, oh, this Ricky. So we never use x minus 3. Adapt me and ask the question.
Stuart.
To sound. Yes, Stuart. Tell me now, why Bogle? Tell me, Bogle, why do I know it is 2x minus 1 that I'm supposed to use?
Sir, isn't it over to the right side? It said x is what? What's saying that? Lesser than. No, hold on. X is less than
read it
minus.
the other way. Read it the other way. Come back. Negative 2 is less than.
I can never read this thing.
You see, Shauna K, you see why I asked the question that way? You see why I asked the question? Because this is why I say to you that I'm only going to do one question in class tonight, because I have to go and have that fulfilled conversation. Right? Now, let me press pause. I'm not getting frustrated because guess what? We're on borrowed time. So I'm not getting frustrated. Let me press pause and let me go to please note. I anticipated that this was going to happen. So that's why I put the please note. Please note. To the left means less than. To the left means less than. And see the less than sign there, sir? To the left means less than.
So x minus 3 now the same sign to, sir.
We're coming here. Love it. Love the conversation. Love it. Learning is such a beautiful thing. So to the left means less than. So therefore to the right means greater than. And I want to yes, honey.
Is it that the number to the left is less than, not the one that's open? It's spacing, not the one that it is spacing, right?
I love it. All right. So I'll come in. All right. I got it. So I heard somebody say, no man, read it the other way around. And then now we hear Shanaki say, okay, I mean, I don't know if read them something here. Less than, greater than. It just gets confused. Could I never read them something here? All right. So what I'm happy about is that you recognize you can read it both ways. Just like an equal sign. X is equal to 2 is the same thing as 2 equals X. Because you can read it both ways. So the inequation signs, or the inequality, same difference, can be read both ways. No. Because we move in this part of the region by reading from the left to the right, because we learn and we read from left to right in this region, in other jurisdictions, they read from right to left. We don't know how they do that. But we read from left to right. So we're going to read the signs from left to right. So we read
Just
it
like
from
when
left.
you drive on the wrong side, sir.
Just like when the other people them drive on the wrong side, don't?
Tell you.
And we drive on the right side. Good.
Of course.
All right. So what is going to happen is, watch me. To the left means less than. Less than. So you see when oh, I don't want to teach you like that. I hear somebody talk about alligator opening and this and that. I don't want to do that.
Sir, that is how I remember it, and that is what I have taught in my world.
Yeah.
So I can read it, because I can read it both ways. So I can say -2 is greater than X. And I can say X is less than -2.
Very
because
good.
I know that the alligator mouth opens to the
greater than
part.
Very good. So okay, so since something said that I can use it because it makes sense. So let us look at this one here. So the alligator, you see where my cursor is. When we talk about less than, where I'm speaking about less than. Let us look at the sign for less than. It's in brackets. So less than is where, if you're reading from left to right, it closes from that point, but the other point is it's open. So you have 2 points on it. So right here, so at this point, at that point right there, so it closes, but at the other end, it opens. So if you're reading it at that end where it's open, it's going to be called greater than. But if you're reading it from that end, it's going to be less than. So that sign is actually less than, but that sign, if you read it the other way, it can be greater than. But guess what? To the right means greater than. Look at what greater than means. Greater than is when it opens up. It means. All right, you need to mute when you use them words. All right. So at that point, wherever it opens up, the alligator opens its mouth, it's going to be greater than. So I want you to stop and to think back to the number line. Sir, what about the number line that you want us to think back? So if you have a number on the number line, let us look at 0. 0. I'm looking at 0 on the number line. When I go to the left of the number line, is that greater than or less than 0?
Less than 0.
Very good. So when I go to the left, it's going to be less than. Don't it? So that's why I say left is going to be less than. So left means less than. So if you look at 0, once you go 0, and you go to the left of 0, you go reach -1. It is less than. So -1 is less than. And if you're at 0 on the number line, and you go to the right, it's going to be greater than. Talk truth. Yeah, man.
So you know how I mark it? Where the point, where the arrow is pointing, I just put a stick in the center of it, like an arrow pointing, and if it's pointing to the right, you know it's a greater than, and if you're pointing to the left, you know it's less than. That's how I work it out, sir.
Very good. Very good. All right. So just remember that now. And as I go through these stuff, things come a little, my explanation gets a little clearer, because this is a weak point in for students, and this point here takes a long time for me to develop, and not just me, but my other lecturers complain about it also. All right, so watch me. We have half an hour. Watch me. We're going to finish the question by then. So remember now. So I think you understand the concept now of left and right, and that left is less than and right is greater than. No, hear me out. I'm going to tell you another secret, you know, because when me I teach me love the story and love the secret, you know. And hear the story now. If you go into the exam, or you do your work on Edicasa, and the man them say to the left, use a zero example on the number line as the example. When you go to the left on the number line, the left of zero is going to be less than, and the right is going to be greater than. So just always remember that. Just use an example and you can catch it. So if you have 3, to the left of 3, you're going to have 2 less than. To the right of 3, you're going to have 4 greater than. So to the left is less than, L and L. To the right is greater than. All right? It ends with R. Right and R. Greater than. All right? Now you know that. But guess what? Less than is going to have, less than is going to, the opening is going to be away from you. Greater than, the opening is going to be towards you. Less than, the opening is away from you. Greater than, the opening is towards you. Less than. Yes, please.
I have a question.
Go
It
ahead.
says you wanted to measure it where you say x is equal to -2, but the top one in the piecewise function where it says x is less than -2, it didn't say x is equal to -2, so that's kind of confusing for me. And then, yeah, the first line where it says x is less than -2, you're asking for the continuous, find the continuous at x, which is equal. It didn't say less than or equal to, it's asking for x that is equal to -2. So within this piecewise function, what I'm asking, does it mean literally you have to work with the top one and the middle one, or it's one or the other, or because it doesn't say, it is not equal to, it just says less than.
Right. And that's why you need to know what less than means and what greater than means.
So, sir.
Yes, please.
Okay, so when you had asked the first question, when you had asked the question before, what you said is, what is to the left of -2 or something to that? And I said -3. You asked me why, and I said to you that because anything that's on the negative is would, sorry, somebody just changed my chain of thought a while ago. But anything on the negative, with anything on the left is on the negative, which is why I came up with -3.
So hold on. I understand what you're saying, but let me just correct something. Something could be to the left, but it's not negative. Because if I start at 10, to the left of 10 is 9, but it's still positive 9. You get what I'm saying?
I understand, but you
All
had
right,
asked.
yeah.
Okay.
Yeah, man. No, man. I know what I asked, and you answered it correctly. But I'm just saying that you said something a while ago, and I don't want anybody else to leave with that and say that when I talk about less than, it's always going to be negative. No. I get your point. I know where you are going, Tamoya.
Okay.
But I just want to correct you so that, and this is why I keep saying that I want you to talk to me so I can get what it is in your headspace. So, yes. So the answer that you gave me, -3, would have been a correct answer. But let me just clear up this. So your answer don't have to be a negative value for it to be less than, because it depends on where I start. It depends on my starting point. If my starting
if the starting point was 2 without the negative, then it would have been what would
like
be
1.
to the left of it would be 1. It doesn't mean that it was negative, just
Very
1.
good. Excellent. So you see the point I'm making. Very good. All right. Very good. So let's continue. Now, so if you look at the function, so it says x is equal to 2. X is equal to 2. So because I'm looking at the function, I'm investigating whether the function is continuous at x equals -2. I must look to the left of -2, and I must look to the right of -2. Just as we did at the start of the question, the start of the course, is the same thing we're doing here. And I did say to you, when I move to piecewise function, I'm going to come back to this. I did say it. And here goes. When I'm investigating if a function is continuous, I have to look at the left of the function and I have to look at the right of it. When I evaluate it, Tashana just said something, but sir, are you going to be substituting? It didn't ask us to substitute. But yeah, we're going to substitute because we now need to look at the left, we need to look at the right. And when we look at the left and the right, and we substitute the values in there, yes, we know that the values are not equal to it, but it only approaches it. So because we're using the calculation or the algebraic approach, we are going to allow the number to be it. If the numbers come out to be of a good behavior, meaning say from the left and from the right, it has said the same something, it means that the function is continuous. If when it moves from the left and the right and the something is misbehaving, meaning say one number from the left and one next number from the right, it means that misbehaving and there is no limit that exists, it is discontinuous. It is discontinuous. So let us check to see what is happening here. So we're looking to the left and the right. Let me just read something here. I highlight what I'm reading. Watch me. You know what? Let me let my story be a little bit bolder. None of you can say can't see my story. What my story is now saying, is that x is tending to -2 in a superscript to have negative sign. That negative sign means to the left. So we are saying here, let me read what this is saying again. The limit as x tends to -2 to the left. And the other one down here says the limit as x tends to -2 to the right. Oh, so sir, in this case, you're using the plus to represent the right and the minus to represent the left. Because remember, when we're looking at the limit of a function, as I told you before, numerous times over, when you're looking at the limit of a function, you are looking at both the left of the function and the right of the function.
And the right. And what Tamara said a while ago, sir, is the same thing that you're explaining now. When you look at the number line where you have -1, then -2, then -3, -2 falls right in the center of both -1 and -3. So we're looking at both sides.
Very good.
Okay.
Very good. Excellent. All right. So look at what is happening now. I am going to remember now for the pair of you, Tamoya and Tashana. Remember now. Yes, we're looking to the left and the right, and Tamoya saying that, sir, like -3. I'm gonna say, yeah, I mean agree. If we are doing the intuitive approach, we would have said no, -2.9, -2.99, -2.999, and so forth and so on. And to the right, you would have said 2.1, -2.1, -2.01, -2.001, but we're not doing that. We are using the algebraic approach, so we're just going to substitute the value inside of it. So here goes. I am looking at the function that is to the left of -2. Watch this. I'm looking at the function that is to the left of -2. The function that is to the left of -2. So can I look at x minus 1 at all? Tell me, yes or no?
No, sir.
Why?
Because x is greater than 2, greater than
Very
or equal
good.
to 2.
Very good. X is greater. And the mere fact that this is greater, it means that it's on the right. True or false?
On the right, sir, true.
Good.
True.
So, me now, and it's I'm teaching something, I'm taking my own little time. I could have done this long time, but I'm taking my own little time because I want to savor every bit of the gravy. All right, let's go. So we know we can't use x minus 1. Sir, me not say all them talk about it, sir. Tell me why again, sir? I can't use x minus 1 for the mere fact that x minus 1 speaks to something that is greater than. Greater than comes from the right. We're not on the right. We are looking for something. We are looking for x equals -2, and that does not give me that gives me positive 2. That gives me positive 2. I don't want negative 2. That gives me, I don't want negative 2. Rubbishness. I want negative 2. But this one here, x minus 1, is greater than a positive 2. I don't want that. That is on the opposite side of the something. All right? Watch me. So what I want is negative 2. So this is it. That's my piecewise function that is highlighted. I'm looking for negative 2. So negative 2, the only two functions that deal with negative 2 will be 2x minus 1 and x minus 3. Because x minus 1 deals with positive 2. So be looking at negative 2, that can't work. So only them two functions here. But sir, which of the function node, sir, of the two functions that you identified, which of the functions, sir, deals to the left? All right, let's just look at the inequality. It says x is less than negative 2. Oh, sir, less than means to the left. Yes. So it means to the, so when you see me put the limit as x tends to negative 2 to the left, remember the negative sign in the superscript is saying to the left. It means that I have to use the function 2x minus 1. I can't use x minus 3. If I use x minus 3, I'm wrong. I have to use 2x minus 1. Why, sir? Because it's to the left of it. See here? It says x is less than negative 2. So I'm going to use 2x minus 1. Now it comes to the point that Tashana was asking, now, sir, are you going to go ahead and substitute the values in there? Yeah, man. We know that it's not equal to negative 2, you know, but we can say to you that it approaches negative 2. So anywhere in the function we see x, we're going to put in negative 2. So it now becomes 2 times negative 2 minus 1. And 2 times negative 2 is negative 4. And negative 4 minus 1 is negative 5. So the limit there from the left goes to negative 5. We now need to investigate the limit as it goes to the right. Watch me. This now brings me to my other please note. Let me go to the please note first, and then I'll come back to that. Number 2. All of this something here, all of this is red. X is greater than negative 2, and x is less than or equals to positive 2. Sir, hold on. We read inside out. We read inside out. So that thing there is red. The inequality there is red. X is
So
greater than.
X is, okay, I see it, sir. I see it, sir.
Emma,
X is
so
greater than negative 2, but x is less than 2.
Less than or
equal to or less than 2.
Right. So we read from inside out. So you see we start at x. So see there's something in blue? There's something in blue, so we start at x. We start at x and go to the left. So we read it. And then we'll go back and start from x and go to the right. So let us go. It says x is greater than negative 2 in a one sense, and in the other sense it says x is less than or equals to positive 2. All right? But we're not interested in the positive 2 now because we are dealing with x equal negative 2. See here, x equal negative 2 up here, so we know now. So the other function that we must deal with right about now, is x minus 3. Sir, tell me again, because x minus 3 says no, it is to the right of negative 2. Oh, because x is greater than negative 2, sir, yes. When it is to the right, sir, it's greater than. I remember you saying that. I remember you underlining the word right. When we say right, it means that it's greater than. Yeah, man. So that's why we're using the x minus 3. No. Anywhere in the function I see x, I'm going to put negative 2. So it's going to be negative 2 minus 3. It's going to be negative 5. Oh, I see the point now, sir. Sir, because it's tending, the function is at negative 2, investigating the function at negative 2. To the right of negative 2 and to the left of negative 2, it is approaching the same value. That means the function is continuous. That's what it means, sir? Absolutely. Absolutely. All right, let us go down and see what it's saying. So since the limit 2x minus 1 going to the left is equal to the limit 2x limit going to the right of x minus 3, then f of x is continuous at x equals negative 2. Oh, so sir, let me just get this straight. So because the limit from the left and the limit from the right are the same number, it means that it's continuous. Very good. And thank you for asking. Okay, sir, and now see them. So that means, are you saying to me, sir, that if when I check the limit from the left and the limit from the right, and I have two different numbers, that it is discontinuous? Very good. Got you, sir. Understand perfectly.
Sorry, I take the conversation out of my head, you know. But yeah, sir, all me I think, you see, Eddie owe me work out all three. He will give me back the same answer. And that's how I get in the exam.
Oh, Jesus. All right, so sir,
yeah.
What you're saying is that when all right, the word continuous also relates to when you're saying it's good behavior, right?
Very good.
All right,
Excellent.
good, sir.
Excellent.
We'll get that one, yes, sir.
Yeah, man.
We just need to work it. We get it.
Are we so bright? Let us finish this one quickly then now. So what we're saying now, so we finish with x equal -2, so we're going to start with x equal +2. Let me just fix up this so that when you copy, so when you go through the something yourself now, you can see it to yourself. Yeah, man. Oh, so in a bright, you know. All right, please. Bam. So we're looking now at x equals +2. So let us go back to the piecewise function. Let us go back to the piecewise function. And when we go back to the piecewise function, we're going to see which functions now deal with +2. So remember, you know, we have to look to the left and the right. Or there's something there. We have to look to the left and right. Sir, me see it, you know, because if you're going to talk about something being continuous, sir, that means say you have to come from the left and come from the right. And it must have a good behavior, as Tashana just said. And once it has a good behavior, then it is continuous. If it is misbehaving, like what JD love to misbehave, it is going to be discontinuous. All right, very good. Watch me now. Watch me. So x equals x equals +2. So if I look at the function, can I again use 2x minus 1? No, sir, because it says x is less than. Less than is to the left. We don't want that. And in any event, sir, it says -2. We don't want -2. We're not investigating -2. We're investigating +2. Right. So we know we have to use the x minus 1. But hold on, sir. We have to go use the x minus 3 again. John, let me see, you know, sir, because remember that's a combined. Very good. And the less than or equals to 2.
In the middle one.
In the middle one, right?
Says x is less than or equal to 2. So both of those have to be used.
Very good. So we have to use the x minus 3 and the x minus 1. Tell me which is to the left and which is to the right. Which of the function deals to the left of 2 and which one deals to the right of 2?
I think the 1 is on the left and the 3 is on the right.
Yes, sir.
You have 2 in the center. X minus 1.
All right. Let me ask the question. Let me ask the question one more time.
2 is a positive number, sir. 2 is a positive number, and then x is showing the negative. X -3, x -1. I'm saying both of them would be on the left side of that 0.
No, not the 0. Come on. Somebody saying something?
Let me mute my thing. Initially, sir, looking at it, because I know I can count 1, 2, 3. I was thinking that the 1 would be on the left and the 3 would be on the right.
No.
But I'm looking at it and
no, you're looking at it wrong, though, Tashana. Don't look at the 1 and the 3, because there's no 1 and 3 on the screen, as a matter of fact.
No,
what
it's a negative 3 and a negative 1.
No, that's not even -3 and -1. It is x minus 3 and x minus 1. That's a function.
Okay.
So what I want you to look at, for me, is the inequalities. The inequalities defines what it is that we're talking about to the left or right. Watch me. Remember, you know, I said to you, you know, when you talk about the left, to the left means less than.
Less than.
To the right means greater than.
Oh.
So when you talk about them something less than and greater than, you have to go look for the inequality, not the function. Okay. So when you find out which is less than, then you write on the function. When you find out which is greater than, then you write on that function. So look back at the look back at the at the piecewise function. Look back at the piecewise function. And I'm saying to you, which of the 3 functions on the piecewise function there deals with x being to the right of 2?
Okay, so x is greater than or equal to 2. So on the right would be x minus 1, and on the left would be x minus 3.
Very good. Duh. Because I'm saying.
Yeah.
True. Yeah, man. So that's exactly what it is. So if I'm saying to you, to the right of 2, it has to be greater than 2. It has to be greater than 2. because to the right of 2 is greater than 2. To the left of 2 is less than 2. All right. So what I'm saying to you now, so yes, so the limit, the right hand side of that limit is going to be the function that we're going to be using is x minus 1. And the left hand side of the limit, no, the function has to be x minus 3. So why x minus 3? Because when you read this inequality sign, negative 2, x is greater than negative 2, but less than or equals to 2. See, less than or equals to 2. Less than means to the left. So the function to the left right here is going to be x minus 3, and the function to the right is going to be x minus 1. See here? The function to the left is x minus 3. See here? X, remember the negative superscript means to the left. So that one there is going to be to the left, and then the x minus 1 is going to be to the right. So having identified the function to the left and identifying the function to the right, I'm going to substitute my value into the function. And when I substitute 2 into the function, remember now, we're using the calculations or the algebraic approach. So we know the function is not equal to 2. It only approaches 2. So we can say 2 minus 3 is going to be equal to negative 1. So we're saying that the limit there, so from the left-hand side is negative 1. Let us check the limit from the right-hand side. It's going to be 2 minus 1, and that is going to be equal to positive 1. Oh, sir, so it's saying the same thing. So that means it is also continuous at x equals 2. Who agrees with that?
No.
Yes, sir.
One a negative and one a positive.
Very good.
Yeah, but both are still the same.
No, hold on.
No, sir had said they had to be.
Yeah, man, they have to be the same thing, you know, Emilio. No, man, have to be the same something, man. So negative 1 is not the same number as 1. Right? So the signs in front of it makes a big difference. Right? So we can say up top, that's something you're not going to, right? 1 a negative 1 and 1 a positive 1 are 2 different numbers, I think, sir. Yes, man, 2 different numbers. And we have to respect the Mr. Negative. When you see Mr. Negative, you call him Mr. Negative because he separates himself big time from the Mr. Positive. Right? So 2 different numbers. So guess what? We can now make a bold statement. Since the limit as x tends to negative 2 to the left is not equal to the limit as x tends to negative 2 to the right, then the function is going to be discontinuous at x equals 2. Whoa, that's the end of the question. Now, Martin, it seems long. It really isn't long, but I have to go through the nuances of my explanation so that we can catch what it is that is happening.
I do really appreciate it, sir. Thanks.
Yeah, man. But do me a favor now. You know all your teacher role, you know. You know all your teacher role. I am smalling it up because I want to. Ouch. Don't worry about. Okay, so there's another part to the question to talk about sketching the graph, but I'm not really interested in that part just yet. We want to build on this thing here first. All right, do me a favor. What I'm going to do is I'm going to push this thing down. You know, I'd love to give you a piece to try on your own. That's the only way you're going to learn. All right, forgive me again. I want to minimize. I hope you can see. I want to minimize so that I can project this one question that I have. Okay, yeah, man. All right, so you don't have to see the piecewise function for question 1. You can see the function here for question. The do know that I want to give to you. It's now 9:51. I'm going to give you 5 minutes to see how far you get with the question. So remember, with this question, you will need. All right, you know what I can do? Thank you, Lord. Let me just copy.
Sure, she want good at question the circle, right? I know it's like my brain doesn't have a frame, but
No man, guess what? Just try this out for me now, Papa. You're good, man. When I say you're good, trust me, you're good. Just try. I'm coming back to do the question, you know. I'm coming back to do the question. I just want you to try to see. All right. Yeah, man. Guess what? This too shall pass, yeah, Papa. All right. So this is not the actual calculation for the stuff. I'm going to type over the stuff, but you will see what it is that I would have done with the first question in this question. So try that for me, please. Take a couple of minutes and just give an attempt to that question. I am going to mute for about 5 minutes.
Sir, I think I have the answer.
Go ahead.
All right, so with the last 3 minutes of the class, anybody got anywhere?
Yes, sir. I got the continue. So it said determine if x is continuous at x equal -4.
Very good.
So the answer that I got for that is using the formulas x 2x plus 9 and half x plus 3. Let me go back on the page for you. Cover the
Very
page.
good.
So that's what I got.
That's what I did too. I think it's discontinuous. I think I don't.
No, I got it as continuous because I got positive one for. Yeah, I got positive 1 for both of them.
And it's supposed to be -4. All right, I'm gonna project this here. 2 seconds. Copy. Paste. What is -4 times a half? That's -2.
Mm-hmm.
And -2 plus 3 is +1.
Yes, sir.
And then we have 2x. 2x plus 9. 2x plus 9. And this is going to be
So 2 times 4 is 8.
-8.
-8. And then -8 plus 9 equal back to a +1.
Very good, Tommy. Oh, can't believe it. Who say understand topic?
Let's see. When me get 100, they tell me some cheat.
All right. All right. So see the first part right here. Look at what it is that I have for the first part, guys. Oops, sorry. Let me just reduce this. Look at the first part there. And see what is happening there. You see the first part? So both of it was -1. Sorry, +1.
A +1. Mm-hmm.
Right. So you can have a half x plus 3. And then it's going to be equal to 2x. 2x plus 9. Very good. All right. So let me just write this here. And put -4. All right. So it is continuous at x equals -4. All right. So I finished the first part. We won't look at the second part. We won't do the, well, I will do this part before I send out the document to you. But I'm going to end the class just at first part. So let me just big it up so at least you don't have to strain your eyes to look at the first part here. So we're looking at x equals -4. So remember now, looking at x equals -4, we're looking to the left of -4 and to the right of -4. To the left of -4, based on the piecewise function given, the left of -4 is going to be a half x plus 3. I hear Sir Headspace kind of tired, and I know why I say Headspace tired because I see the fraction and things it hard. It's not hard, man. And then no, you can look to the right of -4 is when it is greater than -4. See here, x is greater than -4. Reading the other way, so it's going to be 2x plus 9. And having identified those two equations, you put it in here, you write them, and you substitute the values here, and you get both of them to be the same. So you can safely say no, that because they are the same, that's continuous. All right, I'm going to end here. I promise you that it's supposed to be up just 1 hour.
So, sir.
Yeah, sorry, go ahead.
When we get questions like that, you normally give us the guide.
No man, see the question here. What see the question here, hon? The question
No, as in where we have the x less than the 4.
Yeah man.
It's given. Okay.
So what the highlight on the bunches? That's the question, you know.
So you know what I did wrong? I put everything in the calculator, right? And parentheses the -4. So I got 2.8.
Okay,
and
no. No, 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 you know, no, you know.
Everything in the calculator and get 1.
Me don't know how she get 2.8 neither. Maybe calculator never clear.
1 divided by 2 open parentheses.
Use a fraction sign.
Plus 4 close.
No, -4. -4.
Right, -4 plus 3. 2.875.
No man, no man, no man. Go again. Use a fraction sign as somebody say. 1
Sir,
over 2.
I don't know the fraction sign.
ABC to
But
the left.
even if it, oh, but sir, if you even did divide, it still work out to the same thing. 1 divided by 2.
You put it in bracket?
And put it in bracket. Put the 4 in the -4 in bracket. It still works out back to the same thing.
No, not mine. I'm not
All
sure.
right. Okay. Shana, try this. 1 divided by 2, as I say. 1 divided by 2.
Yes, sir.
Equal.
0.
Multiply by -4. Put in 4 and then press the plus or minus button to get it to be -4. Equal. +3 equal.
1.
Ah, magic.
Sir, about that long.
Ah, never mind. You need to get a good calculator, not the Shenko. All right?
Sir, how do I get the fraction?
The fraction ABC. Look to the left. Look to the left of the thing, and you see an ABC button. It could be the third button from the top going down. The leftmost button should say ABC.
Yes, sir. You're right. You're right on point. You know the calculator?
Trust me. Yeah, man. So you just press the ABC button and you get it. Guess what? I am going to find some food I get me eating already, you know. And eat some Roman raisin ice cream. You know, Emilio, eat some Roman raisin ice cream, you know. Jesus, next friend. The ice cream that I
At this
bought.
hour?
Huh?
Donna K just said,
I want
No, me, at this hour.
Me. I don't eat Roman
No, I'm
raisin.
saying at this. No, I'm saying at this hour, sir. You're gonna eat so much food. Is after 10.
Watch me. I will not die of hunger. I can tell you that too. Anyhow, guys, I enjoyed my class. I know it was a long class. I'm gonna do the other part of this question. Send out the document to you, so that you can look at it and just prepare yourself. Right? Bless your heart.
All right. Thank you.
Thank you
Thank
very
you, sir.
much,
We
sir.
appreciate it.
Bless up. Cool.